So when we subdivide mathematics, first we learn arithmetic, right? Maths related to numbers, basic operations, type of numbers like rational number, irrational number, and so on. Number bases, super important for IT, computer science. So then you learn algebra. So that is the maths related to unknowns and variables, right? Things that vary so that we can see how things related, right? Relations, functions, how pressure is related to the volume, the current is related to voltage, and so on, right? A lot of practical usages. Supply is related to demand. Okay, you know supply demand curves in economics, and of course solving simultaneous equations, right, and so on. And that is unknowns. Finding initially unknowns, but after when you have enough relations, you can find find those either equal values or ranges in when it comes to inequalities, right? For example, something like this, right? So then range of possible values that satisfy this. So then you have the geometry, right? Geometry. That is for civil engineers, mechanical engineers. So we don't care much about geometry. For IT, right? We don't care, right? IT, especially for IT, computer science. But anyway, it's an important part in maths. So the next important parts, probability and statistic. Then we have the sets and logic. Of course, this is super important to us. This is super important to us. Okay, this is super important to us. You can see maths is super important to us. Only thing is we don't much care about geometry. Okay, so then we have the next big topic, calculus. Calculus. So this is not directly related to computer science, but indirectly related because we want to understand probability and statistics, and maybe you better understand algebra. Okay, so that is a very important concept, right? But this is more related to other engineering disciplines because there are other disciplines like civil engineering, mechanical engineering, electronic engineering, where we work with continuously changing things, pressure, temperature, waves, analog waves. Okay. But anyway, for us also, if you understand calculus, it's superb because when you learn more and more abstract concepts, so it improves your abstract thinking, it improves your logical thinking, it improves your uh, critical thinking, right? So that you can not only that, then you can even understand the nature concepts better, whether it's natural physics, chemistry, probability, statistic, or whatever, engineering. Then, of course, we have other important items like linear algebra. By the way, you have linear algebra in your syllabus, right? So that we will be cover later, right? Matrices, vectors. So you have this. So this is a big hole, right? So if you don't know calculus, that will create a lot of. Remember, when you go to the industries, private sector, so you are right? Those who have done maths also come for the jobs. So then they have a big advantage knowing calculus, not because they can use it in their jobs mostly, because when they know calculus, they have a additional confidence because they know that they can understand another type of abstract concepts, right? So that is why sometimes you get in the interviews and so on when there's another set of people who have done maths for A level, like computer science in UCSC, computer engineering in Monitor, or some students coming from A level maths, right? So then you sometimes you get a little bit right less confident, right? But knowing calculus and these things, linear algebra, sets and logic, probability, right? Basic algebra, arithmetic, that you will feel like, no, I'm also in the equal level. I can work with them. I can be a part of that team, right? I can face the interview with the same confidence as those guys. So that is why I'm really serious about calculus. Okay, right. So remember, in A level maths, calculus is a big topic. I would say it's about one third or yeah, maybe one fourth of the syllabus. So usually calculus is done taking about 6 to 9 months, right? 6 to 9 months. Okay. But we are going to do it maybe in one day or maximum 2 sessions. So then someone will ask, how do you do it in 2 sessions? First thing is you are not doing A level, you are not kids, right? A level is done by kids, not adults, right? Years, age of 16, 17, 18. But you are not like that. You are more matured. You must have better logical thinking capacity and so on. And number two, we are not going into the depth of A level maths. A-level syllabus. Our task is understand the concepts rather than do a lot of memorizing a lot of formulas and applying those and solve complicated problems. No, our task is understand the concepts, right? Because I told you this is not this is just you relax and enjoy, right? These and see whether you can understand these concepts, right? You don't have exam pressure for this topic. Okay, so those are the two reasons. One, we are not going into the same depth as A level or other engineering maths. Secondly, you guys must be now more comfortable no doing BIT level 1, level 2, right? No understanding computer systems, programming. So you guys must be now more matured to quickly grab it. Okay, right. So let's move on. Uh, right, introduction to this is not calculus. Introduction to calculus. Okay, overview of calculus. Right. So why do we need to understand calculus? Or why do we have a subject called a section in maths, a big section in maths called calculus? So the main reason is, of course, different part of the maths is related to different concept. For example, sets is related to logic, relational theories. Geometry, we can use it in civil engineering, mechanical engineering, right? Measurements, lengths, angles, and so on. Okay? Of course, arithmetic is all about numbers, right? Even you know that computer keep everything as numbers. Whether it's finance or other engineering, right? We quantify things. So whenever we quantify, we need to put it into numbers. Okay? Number bases, number systems, okay? Arithmetic operations. So similarly, why do we have a subject or area called calculus, right? Calculus. Just give me 1 minute. Right. So why do we have area called calculus? Because there are situations where we can't exactly see what happens at that point. For example, if someone asks, say, y equal x plus 2, what is the value of y when x equal 5? So then we know that when x equal 5, it's 5 plus 2, y equals 7, right? Y equals 7. But there are situations we can't exactly find out what is that value at that point. Or it's not determined. Or it's fuzzy at that point. So then we can use, rather than assign a value, like when x equal 5, y equals 7, we try to get it close and closer to that value. Right? When we try to get close and closer to that value and see what happened to this value. So that means we don't substitute, say, x equal 5. We try to reach or limit that value and see what this value is getting close and closer. What is this value is limit to. Okay. So that is called the concept of limit. So the subject of calculus is based on this particular concept of limit. Okay. So rather than we substitute a value, we try to reach that value and see what happened to the results. Okay. So that is called the concept of limit. So that is the basic idea behind calculus. So then mathematicians has built some more useful concepts based on this concept of limit. So two such concepts are what is known as differentiation. You may have seen something like this, and integration, something like this, right? So these two concepts are built based on the concept of limit. right? Based on the concept of limit. So therefore, first you need to understand what is mean by limit, okay, and the applications, idea, philosophy. So then the use of limit, using the concept of limit, what is this, these two concepts, right? Differentiation and integration. Okay, so that is the idea. Okay, so and the other now then we will gradually understand why do we have a subtopic called differentiation, why do we have a subtopic called integration, because these are the real usages, all right? But in order to understand these usages, first you need to understand the concept of limits. Okay, right. If you have any questions then and there, you can quickly ask, right? Quickly ask, quickly clarify, and then move forward. Okay, so that is how it should go, right? So sort of a very basic idea about, remember the two main concepts are subsequently differentiation and integration. So what differentiation is, or what differentiation help us to understand is, now when we have straight line, you know the slope, right? For example, say y equal x, right? You know that slope is any difference in y divided by difference in x, right? For example, this is 0, 0. This is 1, 1. So slope is the tan value of this angle. Or this divided by this, you know that higher slope means something like this, lower slope means something like this. So higher slope means when you move unit of x, then you go more higher value for y. So then we say slope is bigger, right? So that you can calculate. That is not an issue, right? That is very simple thing. For example, if it is y equal x, say this is 1, 1, right? So then you know that this length is 1, this length is 1, tan theta, or the slope is 1 divided by 1, slope is 1. And that is what is meant by y equal x, right? This m is 1. But if it is y equal 2x, the slope is higher. Because if y equal 2x, again it goes to 0, 0. But when x equal 1, y equal 2. Right? So therefore this height is 2, this height is 1. You can take any points. So then this tan theta, or the slope, is 2 divided by 1. So 2 is bigger than 1. So therefore it's a bigger slope, right? And you know that when the straight lines are parallel, they are, how do you call this? Y equal mx plus c. So this is called interception. So this is called slope. What is the other name we use? Uh, what is the other name?
Gradient.
Sorry?
Gradient.
Yeah, gradient. Okay, gradient. So gradient is the idea of slope, tan theta. Right? So therefore, for straight lines, understand calculating the slope is not issue. Not issue. Okay. But what about if we have something like curve? Something like curve. So then you can see that this slope change from point to point. Point to point, this slope change. Right? So we work with this kind of curve, sine curve, tan curve. So you can see this slope change point to point. So differentiation is using the concept of limit. Mathematicians found a way to calculate this slope, right? So then someone will ask, why are we interested in these slopes, right? Can someone tell me why are we interested in slopes? Just, I am not expecting any A level or any other calculus, right? Just you assume you have the O level maths. Why are we practical examples? Just one practical example. Why are we interested in slope? Slope of a line. Forget about this slope of a straight line. But I need a practical from physics, chemistry, right? Uh, Business, economics, that kind of areas. Practical use of this slope, because otherwise, right, you don't know what you are learning, right? So that is useless learning, useless education, right? Sometimes students know everything about y equal mx plus c, right? They know how to solve simultaneous equations, right? What is gradient, what is interception, what is parallel lines, what is perpendicular lines. But when we ask, can you give me one practical example of the knowing the importance of slope? So they are good, right? Speechless. So that is useless education, right? So anyone, any area, engineering, economics, business, science, yeah, know how fast variable change. A slope allows us to see how fast something change. Yes, right. Yeah. So the idea is when you know this slope, higher slope means basically higher the rate of change. Okay. Say for example, say you are climbing up. Say there's a staircase. So higher slope means it's difficult for you to climb. Right. Move up. But if it is lesser slope, you know that that staircase, even an older person can easily uh, use, right? So that means rate of change is less. So we can use it in irrigations, right? And of course, higher speed means, actually, now I will give you the correct answer that you try to give me. Higher speed means your time is less, right? So because you go at a higher speed rather than a lower speed, now same distance you can go at, say earlier it took 1 hour, now you can it take only half an hour. So that kind of calculations you can do if you know the slope, rate of change, because slope is rate of change, rate of change. Okay. But yes, we can calculate the rate of change when it is a straight line, right? When it is a straight line, right? We can calculate. You can take any 2 points, calculate this distance divided by this distance. Because for any 2 points, that is the same, right? This ratio is the same. That is why we call it tan theta, because that is not as long as this theta is the same or straight line, this ratio is the same. That is why we give it a name like tan theta. Okay. So that is from geometry, right? Samanupata trikona, proportional triangles, proportionate triangles, right? So then, of course, not only these division of these two, this divided by this divided by this, right? This divided by this is same as this divided by this. That is, we call it cos theta. This divided by this is same as this divided by this. So we call it sin theta. But that's a geometry, right? So they are because it's a constant speed. Now you can see when you have a straight line, it's a constant speed. At any point, your speed is the same. Whether it's you are moving, okay, so that is you call it velocity or something, or speed, or maybe this is the slope of a staircase, or maybe this is how the rupee rate increases with dollar. If the rupee, the value of rupee change with respect to dollar linearly, yes, then we can easily calculate, predict. So then we have a curve. So what is that rate of change? What we can predict for the near future? So that is something we can understand or better understand when we know slope of curve of a general or slope of a curve rather than a straight line. Because straight line you don't need calculus. Okay. So here you can see, right? Don't think this is only for engineering, right? If you look at say USD to SLR. So these are curves, right? So these are curves, and these are not straight lines. The world, the reality is we need to work with curves. But there are so many places where we have curves in chemistry, physics, and so on. Okay. So therefore, this is one area where we can use uh, calculus or concept of limits to calculate the rate of change at a particular point, right? Particular point because it keep moving, keep changing. So that is called differentiation, that idea or that concept. You will see d by dx. Okay. So that is first usage of calculus or limits. So another interesting usage is area under the curve. Now you know how to calculate area of known. For example, if it is like this, say this is time versus speed. Now you are going at 50 kilometers per hour, constant speed for 2 hours. Now this area is what? Anyone? What is this area? I mean, not the value. Value is of course 50 into 2 kilometers per hour into 2 uh, hour, right? So that is 100 kilometers hour per hour and hour get cancelled. 50 into 200 kilometers. So that means what? In 2 hours, you travel 100 kilometers. So this area under the time versus speed curve is the distance you travel, right? But yes, you can calculate if it is like this. You can calculate if it is like this also. You may have done these kind of calculations, right? So this triangle, this rectangle, and this triangle or this trapezium, right? So this is you are going at a constant velocity. This is you are going at a constant acceleration, constant deceleration. Still you can calculate the distance. But what happens if it is like this, right? Like this. So these are curves. How do you calculate the area? So because that area is the distance, right? But that is just one example, right? So then how you may be wondering how do we get this integration into our statistic? So if you look at this, our statistic note, I'm just showing you the practical usages rather than explaining you calculus, okay? So this is our note, basic statistic. So this UCSC note actually. Which one is fifth one? Now you can see this is area under the curve. So the moment you go to the area under the curve, that is integration. Because you can't calculate like the this width into height or something uh, like that, right? Because this is a curve. Now integration gives you a way to calculate this area under the curve. Okay, okay, just give me one second. Right. So now you must have understanding about why we are really interested about differentiation and also about integration. So this is area under the curve. Area under the curve has a lot of meanings in statistics, right? Uh, Something like civil engineering, mechanical engineering, because it's volume, right? It's the accumulated values, right? Right. We will come back to area under the curve later because that is our last subtopic, right? So this is slope, okay? So this is differentiation, this is integration. When things are continuously changing, not straight lines. If it is straight lines, no, you don't need calculus. Okay, so that is why in your O level, all the questions were referring to straight lines, right? Constant speed and so on. But reality is things are things can be changed. Like actually, reality is more 90% of the time the things that move change uh, not in a straight line manner. Okay, right. So that is why we are interested about limits, because in order to understand, build these concept of differentiation, integration, the basic idea is limit. Okay. So then calculus is all about first understanding limits, then use of limits to build these concepts like differentiation, integration, so that you can use it in right engineering, science, uh, economics, business, everywhere. Okay, much better with much better confidence. Okay, right. So therefore, this is I already explained this. First, we understand limits because this is the basic concept behind calculus. So then you apply that idea of limits in differentiation, integration, and so on. Of course, this is not the end of the story. There are some more advanced topics that, of course, we are not going to touch. All right. If you have a big heart, even you can learn those things by yourself in case you are interested. Okay. Right. So limits, derivatives or differentiation, integral or integration. Okay. Uh, right. Any questions up to this point? Right. So first we will understand this, what value a particular function is approaching. When we approach a particular value, differentiation or derivative, how fast something is changing at a particular point, when things are not just straight lines, and how much has accumulated in total. So how much accumulated in total is integral or integration for the result of integration. Again, the things are challenging when we have curves, because otherwise you can just use normal formulas, triangle, trapezium, right, and so on. But reality is not always like that. So scientists, engineers, we face reality. Civil engineers need to face reality. Mechanical engineers, right? Because just like doctors, right? Doctors need to face the reality, right? Right. So a little bit of evolution. Remember, whenever you learn something, you must understand how these concepts were evolved, right? Because otherwise you don't know, you don't have any sense about it, right? You don't have any feelings about that topic. That is what happened in Sri Lankan education, right? Students just learn things for the sake of learning. They have no feelings about their subjects. They have no feelings about being an engineer. They have no feelings about being a doctor, right? They have no sense about being a entrepreneur. So just they do it for the sake of doing, right? So that is why we say Sri Lankan culture, right? Sometimes they are not serious, right? So they are just like machines, right? Uh, right. So therefore, you must have a bit of a understanding, just like we try to understand the evolution of humans, evolution of uh, economics, evolution of computer, right? Evolution of programming languages. So bit of evolution of how the calculus subject uh, developed into the modern look and feel, right? So this the concept of limit for the foundation of calculus was first introduced. So first they try to understand, document by ancient Greece, in ancient Greece, like mathematicians like Archimedes, right? You know, the time of Archimedes is even before I think even before Pythagoras, right? So this is about 2,500 years ago, right? 2000 to 2,500 years ago. So they start thinking about, actually even before ancient Greece, uh, I think maybe the era of uh, how do you call it? Uh, Egypt, right? Ancient Egypt. So even they had thought about these things, try to build these concepts, but we don't have the documented history. Some documented histories, ancient Greece, especially people like Archimedes. So they try to specially calculate areas of a circle and so on, because this is an interesting problem, right? You can understand that, okay, this is length into width. Maybe this is also half, right? Base into latitude. But how do you prove that this is 5r square? Okay. So this is 2 5r. So these are some interesting things that these people came up with. So actually to calculate this 5r squared and so on, they use the concept of calculus. Of course, they came up with these formulas before calculus was established, but actually they had indirectly used calculus for the concept of limit to calculate this. Of course, if you are interested, go to the YouTube and search history of or evolution of calculus. How these people calculate these areas using some other straight line types. For example, they basically use polygons. And when you have more and more number of sides, the area of polygon is getting closer and closer to the area of the circle. So that is basically, rather than you actually calculate the area, you try to reach that area. So when you increase the number of sides, right, your area is getting closer and closer to the actual area. So that is the idea behind limit, because you can't actually calculate this area straight away. Right? So that is how these things start evolution, right? Then actually at that time they had no idea about integration, differentiation. Those things they later extended, right? Especially in 17th century, that is 1600s, right? Newton and Leibniz formalized this subject, right? Formalized this subject, and they've developed these notations and everything about differentiation, integration, the formal notation for limits and so on, right? So a lot of people, when they say Newton, right, they know Newton's laws, right? Newton's first law, second law, third law. A lot of people don't know that Newton is a mathematician, right? Newton is a mathematician. So both Newton and Leibniz contributed to formalize the concept of calculus, right, in 17th century, that is 1600s. Okay. So then later mathematicians like Euler, right? So they further standardized this and they built more and more advanced, useful concepts on top of these, the concept of differentiation and integration. And today we have a lot of usages, statistic, engineering, science, economics, everywhere. We have usages of these things, and I think mathematicians are keep evolving, keep building more and more concepts of calculus. Okay, right. So that is a bit of a history. So this is a sort of a big picture of the history, like the ancient Greece, like Archimedes, Newton, right? Uh, Basically, the Leibniz came up with these notations, d by dx integration. So therefore, there's a big debate who came up with these, because you can see these two people. Actually, this is a very interesting debate. Who came up with this the idea of calculus first? Formal, of course, the idea came even before, uh, right? But the modern notation is pretty much Leibniz notation, right? Leibniz notation, rather than Newton's notation. Actually, Newton knew something like this for derivative, double dot, some, right? But this notation pretty much came from Leibniz. Okay. By the way, those are very interesting things. If you go to the YouTube, there are plenty of things. Even you can see the research papers published by Newton, Leibniz. So then you can see who has first used these notations. Okay. So then Euler, right, and other people contributed to the subject of calculus. Okay. Right. So in order to understand calculus, as I told you, first of all, you need to understand numbers. Of course, that you must be really experts by now because you are doing computing. Computer represent everything in numbers, right? So that means what is a integer, right? What is a real number, uh, rational number, irrational number, right? At least that, right? You don't need to understand complex numbers, right? Imaginary numbers to understand calculus. But if you have understood those also is for some extent, that is cool because we can extend the concept of limits to those numbers as well. But at least what is an integer, what is a rational number, what is a irrational number, what is a real number, you must understand. Okay. That means you are supposed to know these things because we did that in semester one itself, right? Can anyone tell me what is the difference between rational number and irrational number? Because I know that a lot of students, they don't care. Right? So if when you don't care about simple things, how do you take challenges in complex things? So most of the students, they just want to pass maths exams. They are not serious about understanding this world. Can anyone tell me what is the difference between rational number and irrational number? Because these are the prerequisites, right? Without those understanding, how do you understand more abstract concepts? Irrational numbers can't represent in a number line. So that is wrong. Irrational numbers can be represented in number lines, right? So remember when we say this particular thing, how do you call this? So this is called real number line. Cartesian plane, you have two real number lines. So in the number line, you can represent irrational numbers. Actually, I explained in semester one that how to represent irrational numbers in number line. Okay.
You can't represent it as a ratio of other two numbers.
Other two numbers.
Oh.
But what kind of numbers? The other two numbers is not very specific. So if it is irrational number, you can't represent as a division of integers. So that is why, first of all, you need to understand integer, then rational number, then irrational number, and both rational and irrational together, we call it real numbers. Basically, when we draw Cartesian plane, we have two real number lines. So this is called real number line. So there you can represent, say, the real number line, you can represent 0, you can represent half, which is irrational, sorry, which is rational, half 4.5, right? You can represent 1/3, right? How do you represent 1/3? You break it into 3. So then you can represent irrational numbers. For irrational numbers, you can't represent as division of integers, right? Root 2. But root 2 you can represent, right? 5 you can represent, right? How do you represent root 2 in real number line? Real number line එක root 2 represent can. So this is my 0. Of course, we can take what is a 1 is, right? That is how you start, right? You can define what is 1 is, whether it's 1 centimeter, 1 inch, or any arbitrary value. So then you know what is 2 is, what is half is. 2 is twice of this, half is half of that. So then can you define where is root 2? Of course I can. So how do you find this root 2? Mark this root 2. Say you take one unit, whether it's centimeter or whatever, 1 unit here, then take 1 unit here. So then you join these 2 points. And you know that Pythagoras theorem is a theorem, right? It's perfect, right? Perfect theorem. We can prove it. So then according to Pythagoras theorem, this is 1 squared plus 1 squared square root. That is 1 squared is 1, 1 squared is 1, 1 plus 1 is 2, root 2. So therefore this length is root 2. So therefore if you draw like 45 degrees, then this will be 90. This is 1, this is 1, then this is root 2. So this is how you represent root 2. So irrational numbers you can represent because this is our real number. Real number. Now you can see sometimes what you need to do is think seriously about simple things. Sometimes you assume that you know, I have understood, but in reality, maybe you have not understood, or maybe you have misunderstood. Right. So that is why I ask you to keep a discussion, right? But you guys very rarely get into that discussion. When you get into discussion, only you can find that okay, I have misunderstood this. I have not understood this. Right? So that is why you need to have that discussion with your friends or teachers or whoever. Okay. Right. So therefore, irrational numbers you can represent as a division of integers. Right. But still you can find that value, right? Lengthwise and so on. And there are other ways also. Right. Right. So therefore, what are the different type of numbers? Right. Then basic algebra. Because these curves are represented by algebraic equations, maybe y equal x squared or fx equal x squared. So then you must know what is this minimum point. Okay. So, line of symmetry. Of course, sin x cos x cubic plus 2x plus 2, right? X squared plus 1 divided by x. So that is why we learn about these things in calculus, algebra. Because then we can find, okay, once we draw it, understand it, you can find the slope, area, and so on. Right? So basic of geometry, because that is how you understand what is gradient, what is area. Basic concepts we understand using geometry. Right? So in geometry, we work with circles, lines, triangles, angles. For example, integration, we calculate the slope. Slope is angle, right? Higher slope means higher angle. So that is coming from geometry. And of course, then you must have that critical thinking, abstract thinking, logical thinking, right? So that is not maths, that is basically your skills, your character, your attitude. Right? So then, of course, you can learn calculus. Just like you understand probability, statistic, logic, linear algebra, right? You can understand calculus as well. But you need these fundamentals. Okay. Right. So you must have a very good understanding about what are different type of numbers, right? Integers, rational, irrational, real numbers. What is a positive number? What is a negative number? Right? What is zero? Right? Relations and functions. What is zero? Is zero a number? Is zero a number? Anyone? Anyone? Yes, no.
No.
Zero is a number. So how do you know that zero is a number? We use arithmetic, we use zero in arithmetic calculation, right? For example, 308 subtract 39. So zero is a number. Right? You can use it for addition, subtraction, multiplication, division. So numbers are used for those arithmetic operations. Zero is a number. And what is mean by zero? Anyone? How do you explain zero to someone else? So that is what critical thinking is, right?
Empty.
Sorry?
Empty.
Empty. Okay. Right. I need 5 definitions, 5 examples of zero. Right. One is empty. Another one, maybe just one more example, one more way of explaining zero. Right, I can say yes, empty. This container is empty. Nothing is there. So the other word is nothing. Right, nothing. No change. Right? For example, profit is zero. Maybe profit is 1,000 rupees. Profit is minus 200 rupees. Or you can say profit is zero. That means you have bought it at say 1 lakh and you have sold it at 1 lakh. Your profit is zero. Right? It's not really empty, right? But it's nothing. Right? Something like that. But it's a number. Okay, it's a number. So then the understanding about the negative number. What is mean by negative number? Or negative. What is mean by minus 10? Minus half. Because when we differentiate also, you can get negative values. But ultimately, you will say, okay, minus 5. Integration also, right? After doing the integration, you get minus 3 result. So then how do you understand differentiation and integration if you don't know what is the difference between minus 3 and plus 3? Right? So sometimes you may be thinking that "Well, this guy is asking crazy questions, right? මේ විකාර අහනවාද අපෙන් කියලා. අපි නොදන්න minus කියලානේ. අපි නොදන්න බිඳුව. අපි නොදන්න minus නම් දැන් කියන්න. Can
Losing
yes.
something. Losing something.
Yeah, one interpretation. Again, there's nothing called this is the definition. It can be the way you look at it, right? Yeah, maybe that is losing. For example, you bought at 1,000 and you have sold it at say 800. Then your profit is minus 200. It's a loss, right? It's not a profit. So that is what minus means. Another thing is another example, another way of interpreting negative. Because we need to understand this. මේවා තේරෙන්නේ නැතිවට calculus ගන්න තේරෙන්නේ නැහැ. තේරෙන්නේ නැහැ ඉතින්. වෙන කියන්නේ මොකද්ද කියලා තේරුන්නේ නැහැ. කියනකොට තාම දෙකේ පන්ති එකක් නින් තාම ඉන්නේ වගේ මානසික තත්ත්වෙක. Right? One is a lost. Another way of interpreting it, because it depends on the problem domain. One is lost. Another one. So when you refer to direction, if one direction is positive, other direction you can consider as negative. Right? So that we use when we calculate velocity. Now you know there's a difference between distance and displacement. Dura saha vistapane. So then there are two concepts called speed, velocity. Right? Speed, වේගය, velocity, ප්‍රවේගය. ඉතින් මේවා හරියට තේරුම් ගන්න ඕනේ. දුර කියන්නේ මොකද්ද? විස්ථාපනය කියන්නේ මොකද්ද? මේවා කරන්න මේ A level physics කරන්න ඕනේ නැහැ. ඕන මනුස්සයෙක්ට මේවා ගැන හැඟීමක් තියෙනවා. So we call them vectors. Vectors. So vectors has a direction. For example, force, it's a vector because you apply that force this direction versus this direction. දැන් මනුස්සේ කාර් එකක් තාලු කරනවා කියන්නේ එයා මේ පැත්තට තාලු කරනවා. තව එක්කෙනෙක් මේ පැත්තට. එතකොට ෆෝසස් දෙක එකතු වෙනවා. හැබැයි එක්කෙනෙක් මේ පැත්තට තාලු කරනවා අනිත් එක්කෙනා මේ පැත්තට තාලු කරනවා. එතකොට මේ කාර් එක යන එක වළක්වන්න මෙයා පුතාද? Same say this is 100 Newton, this is 50 Newton. 150 this way, 150 Newton. 150 this way, only 50 Newton this way. So then we can, if you take this direction as positive, maybe you can take this direction as negative. So likewise, the concept of negative has a meaning. And it can be a loss, it can be the opposite direction. Right? It can be decreasing. Differentiate කරනකොට අපිට negative වෙනවා කියන්නේ ඇත්තටම rate of change එක වැඩි වෙන්නේ නැහැ. අඩු වෙනවා. For example, if you go like this is positive rate of change. Right? But this is negative rate of change. So if you calculate the rate of change at these points, actually you will get a negative value. So similarly in integration, if it is above the x-axis, we get it positive. Sometimes you get below the x-axis area. Then you get a negative value when you integrate from this to this. So likewise, you must have idea about what is this negative numbers are. Why do we have a concept called negative? Because මේවා නැතුව foundation නැතුව ඔයාලට මෙලෝ දෙයක් කරන්න බෑ. හරි? මෙලෝ දෙයක් කරන්න. බිඳුව, ඍණ. So then the difference between continuous and discrete. Right? What is mean by continuously changing? What is now? Remember, our statistics subject is subdivided into random statistic related to discrete random variables, statistic related to continuous random variables. So then you must know what is mean by continuously changing, like analog signals versus discrete signals. Say 1 0 1 1 1 0. This is discrete. All of a sudden change. This is analog, gradually change. So what is mean by continuous change or continuity? Okay. So then you must have very good done. The මේවා calculus මේවා දැනගෙන ඉන්න අයට තමයි calculus උගන්වන්නේ. මේවා ඔයගොල්ලෝ දැනගෙන ඉන්න ඕන O level කරද්දී හරි. So what is mean by infinity? Because these are the මෙන්න මෙතනින් එහාට තමයි අපි ඇත්තටම calculus කියන්නේ මේ ටික දැන්නම දැනගෙන ඉන්න ඕන. හරි මේ ටික. Relations and functions, zero, of course numbers, change, what is mean by change, what is mean by continuous, of course මේක දාන්න negative numbers. Right? Infinity, what is mean by infinity? මොකද මෙතනින් එහාට අපි කරනවා limit වල ඉඳලා. හරි. හරි මේ ටික දැනගෙන ඉන්න ඕන. Can someone explain what is mean by infinity? I explain it taking lot of times in semester 1 basic maths or introductory maths. Anyone? Because remember, when you give an answer, make sure, of course, I am not expecting the perfect answer from you guys, but when you go for interview, right? It's a competition, right? When they interview, say, 5 people, maybe they only select 1 or 2, 3 of the, right? That is normally, right? So when we need 2 people, usually we interview at least 10. So then remember, life is not always positive things, right? Win, right? Most of the time you get defeats in life, or majority get defeats. Minority get, right? Minority get wins. For example, say you are playing for a, right? You are playing badminton, individual player. You are playing table tennis, right? So then majority you may get defeats, or majority you get wins. But if you are a good player, better than average player, right? Majority you get wins. Others, majority you get, right? Majority of the players will have lost. What is the average value? What is the average value? Win versus lost for a player. Anyone? I'm asking a probability question, statistic question. Say you are playing chess, I am playing chess. Okay. I can show you. Do you understand my question? What is the average value of a player's win versus lost playing chess or playing cricket? Sorry, playing table tennis or whatever. Average.
Getting a good experience
No, I'm
or
not asking
good
individual,
match.
right? As players, right? As players, if you take all the players in this world playing chess, right? What is the average, or what is the probability, most likely value? That is called expected value, right?
Loss,
Are you sure? So I'm
I
not
think so.
asking about individual. Say there are say 1 million chess players. My question is, what is the average value of winning? Consider all these million players. Now I'm asking practical question, because that is what life is. And not memorizing things. Apply these concepts into statistic, probability into real world.
So can you repeat the question, please?
Say there are 1 million chess players in this world. Anyone can play with anyone else, right? You can decide. Okay. So just assume it's random, purely random. Okay. My question is, what is the expected value of a win for any player? Expected value. It's statistical answer I need. Just it's 100% randomized. Just randomly you play with each other. You don't have any choice or preference. And don't refer to one player, right? In general, for players, they play with randomly each other.
Half,
Sorry,
half.
half. Yes, that is the correct answer.
But it depends on the experience, right? Someone will get
I'm
higher
not talking
probability,
about one
some
player. I'm talking about the average expectation of taking entire sample space, entire 1 million players, because they are playing with random players. Sometimes you maybe you play with the grandmaster also randomly, if that person is selected. At the same time, maybe you are playing with another very junior player. It's 100% random. If it is 100% random, right? I am not talking about X or Y or Z, right? What it's like tossing a coin. It's like tossing a coin. So what is the percentage of getting head? Right?
Ah,
Half. So I'm not talking about you. I'm not. If you are a better chess player than me, yes, you have a better chance of playing, winning. Maybe your chance of winning is 60%. My chance of winning is 40%. But I'm not talking about you or me. In general, what is the expectation of a player to win if it is 100% randomized? Right? Okay, because every match there's a winner, there's a loser. That is how you look at it, right? Whenever there's a end or there's a tie. But tie means no one is winner, no one is loser, right? So therefore that is also fine. But at the end of every match, there's a one winner, one loser, right? Every match, one winner, one loser, one winner, one loser. So therefore, if it is 100% randomized, the expected value is 50. It doesn't mean that everyone's percentage is 50. No. Weaker players will have maybe 20% of winning. At the same time, the strong players will have maybe 70%, 80%. But again, this is distributed like this. That is called normal distribution. Anyway, we are going to look at that later. Right? If it is 100% randomized, so this will be 0.5 probability. Right? And that means you don't have any choice, right? Some system randomly decide, okay, you two guys need to play now, but it's purely random, 50%. So therefore, not your the player's expectation for win is 50%. But when you go for interviews, what is the expectation of a candidate getting the job? That is what I want to come to. That is my real question actually. I just give this question just to make you think. Right now, my question is: I told you when you need two people, usually we take about 10 people. We interview about 10 people, right? So when we need two people, let's say every organization they at least interview 10 people when we need two people. That is normally the case. I'm not saying exactly 10. When you need to exactly you interview 10, but maybe sometimes they interview 20, sometimes they interview 6 and select two. But let's say this is the general scenario. Most likely, when you need two, companies will uh, interview at least 10, roughly 10, maybe little less than 10, little bigger than 10, but roughly 10. Now, my question is, right? If a someone, not you or I or someone else, right? In general, when someone goes to the interview, what is the expected value of getting the job? Earlier, expected value of winning the game for if you are playing chess games randomly 50%. Now, what is the expected value of one getting one, right? Getting the job, getting the job offer. Is it zero? Is it one? Is it half? Or is it something else? Assume that on average, when a company needs two, they will interview 10. When they need 20, they will interview 100. Of course, that also again varies. Sometimes little bigger, more than 100 or lesser than 100, but maybe 100 is a 100 though. For 20, 100 is a expect a natural value. For two, 10 is a natural value. For one, you roughly interview 5 people, but one will get the job. Now, my question is, what is the expected value of someone in this world getting the job when that person goes to a interview, job interview?
Point two.
Point two as a fraction. If you put it as a fraction,
2/10.
2 over 10. Yes. That is why I told you, when you go for interviews, I'm not referring to X or Y or Z. Right? Expected value is majority you are going to face, you are not getting the job or you fail your interview. Right? This is not for X or Y or Z. This is the normal situation for a random person. Right? So that means 2 out of 10 means 1 out of 5. When you go for 5 interviews, not you or me, right? Expected value, 4 times you don't get the job or you are not qualified. 1 times you are qualified. So that is why I told you in life we get more defeats. Again, it depends, but not everyone. Right? Sometimes someone will say, okay, I have faced 5 interviews and I got all 5 jobs offers. Another person will say, I went for 5 interviews, still I am jobless. None of interviews, in none of these interviews I was selected. Another person will say, when I go for 5 interviews, I got 2 offers. But expected value is 1 out of 5. If this is the normal scenario. So when they need 2 people, they take only 10. Now you can see this is lesser, right? But in chess, every time there's a winner, there's a loser or tie. That is why I told you in reality, expect this. This is called expected value. Expect the reality. Right? Expect the reality. This is why you learn probability statistic. Right? Now maybe you guys are in early 20s, right? Early 20s. So you must know what is the expected or we call it life expectancy. Right? Life expectancy. In Sri Lanka, right? For females, males. So for females, it's a little bit higher than males. Right? Maybe I think somewhere close to 70 for males, maybe females 70 to 80. So that is the reality, right? So දැන් ඔයත් කවදා හරි වයස දැන් ඔයාට වැඩි මම ඒකට ලං වෙලා ඉන්නේ. ඕගොල්ලෝ 20 ගණන් වල ඉන්නවනේ මම දැන් ඉන්නේ 50ක් පැනලා. එතන මම දන්නවා ඉතින් එක්ස්පෙක්ටන්සි කොහොමද තමයි කිව්වේ. ඔකත් එක්ක අපි තරම් කරන්නද නෑ. So we face the reality. Right? අඬින්නවද නෑ. So that is why you learn calculus, right? It doesn't mean that everyone will live, say, 70 years. No, some people will even die within few days. Some people in their 20s, 30s, some people 80s, even go for 90s. So that is why you learn statistics, probability, right? Right. So my question is, what is infinity? Because from this point, we start our subtopic.
Something is very large, like there is no limit.
Yeah, something very large, right? Like how large? Limitlessly large. So that is called infinity. Right? If there's something which is very large, it is not thousand, it is not million, it is not trillion, it is not trillions of trillions, right? It's even beyond that. So if you can think like that, something very large, right? Without limits, right? Without bounds, you can think, right? That is why you have the imagination. So then we say it's infinity, either positive side or negative side. Right? Positive side or negative side. So then we call it infinity. If it is positive side very large, positive infinity. Negative side very large, negative infinity. Okay. So that is a concept. That is not a number. Right? 0 is a number. Infinity is a concept. Okay. Infinity is a concept. That is why you don't do arithmetic operations with infinity. Of course, you can do it, but not like normal arithmetic operations, right? For example, you know that 5 into 0 is 0, right? Then you can use that 0 inside your numbers, 305, but you don't see infinity inside numbers, right? Because infinity is a concept. And there are so many situations, right? For example, you know what is 0 minus 0, but you can't calculate what is infinity minus infinity in normal way. Okay? what is infinity divided by infinity, right? And so on. Of course, in that case, 0 divided by 0 is also not something determined. So we call them indeterminate situations. There also we can use calculus. So that is a beauty of calculus. When you ended up with 0 divided by 0, infinity divided by infinity, infinity minus infinity. So those things you can't use normal arithmetic operations, algebra to find out what is the actual value. But actual value you can calculate using limits. For example, when you try to use normal algebra and just substitute, you ended up in 0 divided by 0. But when using calculus, you will find that, okay, that scenario is actually fine. Not right. So therefore, 0 divided by 0 is not 0. Because sometimes when you just look at it, 0 divided by 0, if you assume it's 0, yes, right, 0. But actually, when you're using calculus, you actually calculate it, you find that, okay, that is not 0, that is 5. So then how can you say that 0 divided by 0 is 0? Okay. So how can you say that infinity divided by infinity is 1? Sometimes, actually, when you look at it using calculus, this will end up as minus 3 or 8 or 20. So that is another use of calculus actually, limits. Okay, limits. Actually, that use we are not much interested for this discussion. Okay, right. So therefore, infinity is not a number. Infinity is the concept of very large. So when you learn calculus, you will learn some more concepts, right? What is limit? You will learn what is infinitesimal, delta x, or this either you use simple delta or capital delta. So this is another concept you will learn, infinitesimal. So this is not infinity. This is infinitesimal. සිංහලෙන් කියන වෘද්ධියක් කියලා. ඉංග්‍රීසියෙන් කියන infinitesimal. Right? So then you need to understand what is mean by convergence. Right? So these things we will be learning. Right? What is mean by converge to a value? Right? That of course we learn in our semester one. No, you never had the sequence and series in semester one, right? So then of course rate of change or the slope rate of change of a continuous things curve, that is differentiation. Then okay, differentiation. So then accumulated area of continuously changing curves, integration. So this is what you are supposed to know, right? If you want to have that same confidence as others. මොකද මේව දන්න අය එක්ක ඔයා ඉන්නකොට නැත්නම් නිකන් පොඩි අර අපේ හීනමානයක් කියලා. So you feel like you are small, right? Right? You are less privileged, no, right? Education is not a privilege. Education is a basic need, right? Only thing is, do you really need it? Do you really need it? Right? If you want to get into the same level of thinking. Right. So now let's move on to limits. Because this is the basic concept. Again, we can reach this subject at very basic way, at very advanced manner. We are going to learn these sub concepts at a very basic level. So therefore, don't think that at the end of this discussion, you know everything about limits. So there are some other alternative ways of proving these concepts, right? We call it rigorous proofs, right? Rigorous proofs. We are not going to look at those things. We are just going to look at this in a very innocent manner, okay? Okay, because I told you this is for about 1 year. Actually, in universities also we learn limits, calculus. In engineering, right? Semester year 1, year 2, year 3, we have maths. But that maths is on top of A-level maths. Right? In our universities, we learn maths. We don't learn anything that we have learned in O-level or A-level. From day one, on top of A-level maths, we learn maths. So that means not only, for example, myself, I have done engineering. I have done my A-level maths. So then year 1 maths, year 2 maths, year 3 maths, year 4 maths. Right? No overlapping. Anything that we have learned, I had learned in A level, it's not repeated in university. So, right? So what we are going to give you is little bit of A level maths. Right? Even today, when someone is passing out from University of Moratuwa, so that guy has A level maths plus 4 years of maths. Okay. Finally, maths is optional actually, but most of the students do it. Right? So you can't say you don't come to this interview, right? ඔයාට කියන්න බෑ ඔයා මේ interview එකට එන්න එපා කියලා. එහෙම කියන්න බෑ. එයාට A level එකේ thinking එකකින් එයාට පුළුවන් යමක් දිහා බලන්න. යමක් දිහා බලන්න, ලෝකෙ දිහා බලන්න. ඒතර ඔයාට අඩු ගානේ මේ basic concepts ටිකවත් දාගන්න එපා නේද? Right. So as I told you, limits is the basic concept behind calculus. So using limits, we can build concepts like derivatives or differentiation, integration, and so on. So therefore, in order to understand these things, first you need to understand what is limit is. Okay. So what is a limit? So limit is the foundation that connects change and accumulation. So that means differentiation and integration and some more concepts actually. But we are more interested about change and accumulation because we are more interested about differentiation and integration. But that is the foundation. Okay. For derivative, integration, continuity. Okay. And you will better understand what is infinitely small, right? Infinite processes, and so on. When you understand limit. Okay. Right. So what is a limit? Right. What is a limit? Remember when you have function, remember we have done relations and functions. It's algebra related topic. Say fx equal x, fx equal x squared plus 2, fx or gx, fx equal x squared divided by x plus 1, or fx equal log 2x. Okay. Fx equal sin x. So you can find what happened to fx for given x, right? That is where you learn domain, right? Range, codomain. Okay, so those things you have learned, right? In your level 2 maths, semester 2 maths. So you can substitute, right? For example, what is f of 5? Say that is 5 squared plus 2, 27. Therefore, f of 5 is 27 or y is 27. So this is, remember, one variable things. One variable things means 2 dimensions. So then maybe f of x comma y, x squared plus y, then it is 2 dimensional. Sorry, 3 dimensional. ඔගොල්ලෝ 2 මේ ඇත්තටම ඔගොල්ලෝ වැඩ කරන්නේ 2 sorry, then it is 3 dimensional. X, Y, Z. This is your Z. Remember, if you are a civil engineer, do you work with 2-dimensional things or 3-dimensional things? ඔගොල්ලෝ දැන් maths එක ඉගෙන ගත්තේ මොනවාද? 2-dimensional maths. ඒ කියන්නේ y x සහ y විතරයි තියෙන්නේ. නැත්නම් fx x. හැබැයි engineers ලා වැඩ කරන්නේ 2-dimension එකේ නෙමෙයි 3-dimension එකේ. Right? When you build a bridge, it's 3-dimensional, right? Dam, 3-dimensional. Machine, vehicle, 3-dimensional. So therefore, engineers face reality. ඒගොල්ලන් 2-dimensional මනක්කල්පී ලෝකෙ ඉන්න බෑ. Right? Aeronautical engineering plane එකක් යන්නේ 3-dimension එක. But anyway, the concept of relations you can then continue. එතකොට අපිට යුනිවර්සිටි එකේ ඉංජිනේරින් කරන්න ගියාම මේ මැත්ස් ඉගෙනගෙන ආවට යන්නේ අපි ඉගෙන ගන්න ඕනේ මොකද්ද? 2 variables එක. 3 variables එක. මොකද ඒගොල්ලෝ දැන් පස්සේ සිවිල් ඉංජිනේරින් කරන්න යන්නේ, මෙකැනිකල් ඉංජිනේරින් කරන්න යන්නේ. And also when it comes to data analysis, is it only one variable? Only two things are related? No, sometimes there are three things related, four things related on, right? That is a reality when it comes to market analysis and so on, right? So therefore, again, you need to understand these two, three variable, four variable things. That is, you get into the three dimension, four dimension, five dimension. So that is your imagination, right? Beyond third dimension is your imagination. Right? You can extend it to nth dimension because there can be things interrelated, right? Not just two things, three things, four things. Okay, right? Forget about that because as professionals, we need to face the reality, right? We need to නේද ඔයා ડોක්ටර් කෙනෙක් නම් සමහරට ලෙඩා එනකොට නේද හැප්පිලා චොර වෙලා නේද මරි බාහනයකට යට වෙලා බෝම්බ එකට අහු වෙලා ඉතින් දොස්තරට කියන්නමද අපෝ මට නම් මේ චූටි කැපුමකට නම් බේරක් දාන්න පුළුවන් අනේ මෙච්චර අමාරු ලෙඩු බලන්න මට බෑ කියලා, right? So that is why we need the best people get into the medical college, right? They must have the courage to handle complexity. Doing almost impossible things possible. So that is why we need the best people. So that kind of a technical complexity is handled by engineers. කනිතර හිතාගන්න බැරි building හදනවා. නේද? උමගවල් හදනවා. So that is why you need this big brain power, right? Thinking power, critical thinking, analytics, logical thinking, whether you are in software development, right? Software development is also like that, right? සාමාන්‍ය මිනිසුන්ට හිතාගන්න බැරි complex system හදන software engineers ලගෙ. Right? AI engineering, data engineering. Others, they can't think about it. Then now now you are supposed to start your project, right? සමහරු දැන්ටමත් වැඩේ පටන් ගත්තා හිතනදී යකෝ මේක කොහොමද කරන්නේ? Right? So ඒක කොහොමද software engineers ලා කරන්නේ? So that is all about your potential, right? If you have that potential, you can start the project now. You can continue building your project. But sometimes you may feel like දොස්තර කෙනෙක් බය නැතිව ලෙඩා බාර ගන්නවට ඔයා ගිහලා ලෙඩා බාර ගන්න නෑ. So that is why you learn semester 1 semester 2 database, web development, mobile development කී subject ඉගෙන ගන්න ඒකට. So then to build your character you learn maths and other things. Right? It's software engineering, object oriented system analysis and design and so on. Right? So therefore what is limit is not assigning a value and find the calculate it. No. You don't assign the value, rather you getting close and closer to value. That means you don't assign 5. You are getting close and closer to 5 and see what happens. What is the result of this? Or you can say rather than say f5, you can say limit when x is getting close and closer to the 5, what happened to this fx? So then someone will ask, why don't you just assign it and find it simply? There are situations you can't do that. Or when you assign it, you get this kind of scenarios like 0 divided by 0, infinity divided by infinity. But when you use limits, okay, then you get the actual value. Say 5, 3, 9, half. So that is where we use limit. Is it correct? Sorry, is it clear? Limit describes the value that a function is approach getting closer. That is called limit, SEMA. As the input get closer to a particular number. So when this input getting closer to this number, what happened to this f or fx? Not f5. We don't look at f5. X when x is getting closer to 5. So then we say that this is the limit of fx when x reached 5. So why do you do like that? Because there are situations just substituting doesn't give you the value, or it's not possible to find using conventional maths, conventional arithmetic and algebra. Okay. Sometimes your limit value is same as the value that you get from substitution. right? That means when you substitute, you get a value. Same value you get from the limit. So actually, that is what happens most of the time, right? 99.9% of the time. But there are situations when you substitute, you can't calculate it. But when you use in limits, you can get the value. So that is where the limit is really, really useful. Okay, is it clear? So therefore, idea is we reach it. We reach a particular value, right? So then see what happened to this value. That reached to this value. So therefore, we say that okay, the limit value is this. When x getting closer and closer to a, my fx is getting closer and closer to this value. Maybe this value is 5. Okay. So when we getting closer and closer to this is getting closer. And you can see at this point it is this. At this point it is this. At this point it is this. Right? That is when you go from here to here. Then from here to here also you can. At this point it is this. 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 Now you can see from this way it is getting closer to this. From this way it is getting closer to this. Then we say when x is getting closer to a, my fx is limit to L. Because that is where it reach, right? So it is sandwich වෙනවා කියලා. හරි. මෙයා එන්න මෙයාට ලං වෙනවා. Okay. So then someone will say, okay, that is always the case. නෑ සමහරවිට එහෙම වෙන්නේ නැහැ. සමහරවිට එහෙම වෙන්නේ නැහැ. සමහරවිට මෙයා මේ පැත්තෙන් මෙහෙම ලං වෙලා මේ පැත්තෙන් හිටුවා මෙන්න මෙහෙන් පාත් වෙනවා. හරි. නැත්නම් මෙයා මේ පැත්තෙන් මෙහෙම ගිහිල්ලා මේ පැත්තෙන් මෙන්න මෙහෙම මතුවෙනවා. හරි. So there are situations like that, especially when it's involved infinity and so on. Or sometimes there's a hole here. It's not continuous at that point. Okay. These things are like the real world. ඔගොල්ලෝ දැකලා සමහරු ඉන්නවා මේ relationships කියලා තියෙනද කෙල්ල කොල්ල අතර එන්න එන්න ඒ කොල්ල එන්න එන්න අර කෙල්ලට ලං වෙනවා. අර කෙල්ලට ලං වෙනවා. ඒතර අපි හිතනවා හරි දිගටම අර කෙල්ලට ලං වෙනවනේ. අපි හිතනවා දැන් අපිට තව අවුරුදු 5කින් හම්බුනම දැන් මුන් දෙන්න බැඳලා ළමයි හම්බ වෙලා ඉඳී ආදරෙන් ඉඳී කියලා. සමහරවිට මෙහෙම ලං වෙනවා තමයි අපිට පේන්නේ. හරි. පළවෙනි අපි යුනිවර්සිටි එකේ කියලා පළවෙනි අවුරුද්දට වඩා දෙවෙනි අවුරුද්දේ ලං වෙලා ඉන්නවා පේනවා. ඊට පස්සේ නිතරම හම්බ වෙනවා. දැත්ත නැතුවම බෑ. හැබැයි කැම්පස් එකෙන් අවුට් වෙලා අවුරුද්දයකට විතර පස්සේ හම්බුනාම කියනවා මම මේ ගම වෙන කෙනෙක්ව බැඳා අරයා වෙන කෙනෙක්ව බැඳා. ඒක මොකද ඒ? කියන්නේ මෙහෙම ලං වෙච්ච පළියට එහෙම සමාන වෙන්නේ නැහැ. සමාන තැන්. මෙහෙන් කියන්නේ ඒවා ඊටුවා මෙහෙම මතුවෙන්නේ නැහැ. හරි මෙහෙන් ආදරය කරලා මෙහෙන් වෛර කරනවා. So reality is like that, right? Whether it's human life, right? දවල් පේනවනේ හිතුවා මෙහෙම ගිහිල්ලා ෂෙයා මාකට් එකේ මෙහෙම උඩ ගිහින් ඊට උගක් කඩවන්න. There can be a reason, right? Right? There can be a reason. Sometimes we can even predict. මෙහෙම යනකොට මෙහෙම වෙනවා කියලා අපි දන්නවා තමයි. Right? For example, ෂෙයා මාකට් වගේ මෙහෙම උඩ එහෙම සමහරට සයිකල් එක අපි අද කරන අවුරුදු 3කට සැරයක් එහෙම වෙනවා. මෙහෙම ගිහිල්ලි වෙලා මෙහෙම වැටෙනවා. ආයි මෙහෙම ගිහිල්ලා මෙහෙම වැටෙනවා. ආයි මෙහෙම ගිහින් මෙහෙම වැටෙනවා. මේව හරියට අඳුරගත්ත මිනිස්සු තමයි හරියට ඉන්වෙස්ට් කරන්නේ. මෙතෙන්දි විකුණනවා. ආයි මෙතෙන්දි ගන්න. නැත්නම් මේ හරියට ගන්න. මෙතෙන්දි මෙන්න මේ හරිය විකුණන්න ඕන. මේක පැන්නට පස්සේ මෙහෙ වෙනකොට ඔන්නයට විකුණලා වැඩක් නැහැ. So you must know when it is going to turn down, right? Like that. ඒක maths වලින් විතරක් නෙමෙයි. Your economics, politics, right? World affairs ඒ ඔක්කොම දැනගෙන ඉන්න. හැබැයි ඒ අතරතුර එහෙම trends තියෙනවා. Trends පේන එක තමයි intelligence කියන්නේ. So that is called intelligence. Right? When others can't see the trend, you can see the trend. That is where you become a scientist. That is where you become an investor. Right? That is where you become a successful politician. Right? Trend එක බලලා හරියට address කරනවා. ඡන්දෙ දෙනවා. ඡන්දෙ දෙනවා. That is intelligence. Sorry, ඒකට A level maths මම දැන් ඕනේ මේ sometimes what you need is emotional intelligence. මිනිසුන්ගේ හැඟීම් තේරුම් ගන්න ඕන. But doing maths is always so good. අපි දැන් මේ දවස්වල ලංකාවේ ඉන්නේ A level maths කරපු කෙනෙක් නේද? maths කරලා යුනිවර්සිටි ගිය කෙනෙක් නේද? ඒගොල්ලෝ. හරි. ඉස්සරහට maths කරපු අයත් එක්ක හැප්පෙන්න බෑ. maths IT ඉස්සරහට IT කරන අය A level maths කරන නැත්නම් මේ maths ඉගෙන ගන්න අයත් එක්ක හැප්පෙන්නේ නැහැ. මොකද ඒගොල්ලෝ මේවා ගැන අනිත් අයට වඩා සීරියස්. අනිත් අයට වඩා ටිකක් බුද්ධියක් තියෙනවා කියලා පේනවා. අනිත් අයට වඩා. අනිත් මිනිස්සු ගොන් කතා කියනකොට අර මිනිස්සු අඩු ගන්න ගොන් කතා කියන එක අඩුයි. හරි? ලොජිකල් තින්කර්ස්ලා. මැත්ස් වගේ සබ්ජෙක්ට් වල මේ කන්සෙප්ට්ස් එක ඇඩ්වාන්ස් කන්සෙප්ට් හිතන කට්ටිය. ඒක විභාග පාස් වෙලා දැන් මේ ලංකාවේ ඉන්න ජනාධිපති A level පාස් වෙන යුනිවර්සිටි ගියේ නේද මැත්ස් කරලා. එයා කැල්කියුලස් එහෙම කළා නේද? නැත්නම් එයාට A level පාස් වෙන්න බෑ. මට තේරෙනවා එයා කතා කරනකොට එයා අනිත් මිනිසුන්ට වඩා පොඩ්ඩක් තියනවා කියනවා. එහෙම මේ A level මැත්ස් කරපු පරියට මිනිස්සෙක් මෝඩයෙක් වෙන්න නැති වෙන්නේ නැහැ. එහෙම ඕන තරම් මෝඩයෝ ඉන්නවා. ගොන් කතා කියන. හැබැයි වැඩි there's a higher probability, right? When you are familiar with these high level concepts, right? So you can survive, right? You can be little bit smarter than others. Okay? Right. So that is what limit is. Okay. That is what limit is. We try to look at what happens when we reach a value rather than simply substitute the value. Because sometimes when you substitute the value, you can't find the value. Right? Or it is not the determinant. But there you can find the value. Okay. Right. So we can use this concept of limits as a simple concept as a limit. Okay. And also later on, when we build concepts like derivatives, integrations, right? We 100% depends on the concept of limit. Okay. Because you can't just substitute and find those values. Gradient value, slope, area, you can't substitute and find. It's only way is you limit, you reach the value. Okay. Right. So these are the two the main usages. One is differentiation or derivative. The other one is integration and other one is integration or integral. Okay. ඒ ගැන බය වෙන්න එපා අපි පස්සේ කතා කරනවා. Okay. Integration. But just to give you a hint, if you have not done calculus, so the idea of differentiation is, remember when we have a curve, of course, if you have straight line, everywhere the slope is the same. And you don't need differentiation, right? Because everywhere at any point that is, say you are traveling at a constant speed. So at t equals 0, t equal 1, t equal 2, everywhere say your constant speed is maybe 50 kilometers per hour. So then you don't need any, but maybe you are accelerating like this. Okay, just give me 1 minute. I want to connect my power laptop. Okay, so if it is straight line, yes, no issue. You don't need calculus. But what about you are traveling like accelerating? Like this. Now at that point, speed is like this, rate of change. Now you can see you are keep increasing your speed. Acceleration means your speed increase. ඔය වාහනයක නැගලා accelerate පාගනකොට ඔයාලට පේනවනේ කටුව වැඩිනවනේ 20, 25, 30, 40. Actually you are traveling your distance versus time is now like this. This is your speed. ඒක තමයි කටුවේ පේන්නේ මේ වැඩි වෙනවා කියන්නේ. Then deceleration is like this. Your speed is getting lesser and lesser. So how do you find that kind of a rate of change? There's a way to do that. You take two consecutive points and calculate the rate of change. But then it is a straight line, but that is not your actual curve. But when you keep this smaller and smaller, you call it delta x, right? Infinitesimal. When you make it closer and closer to 0, that straight line become tangent line. ස්පර්ශකයක් බවට පත් වෙනවා. මේ cross කරපු line එක when your delta x is getting closer and closer to 0, right? It become a tangent. If this is the curve, that become a tangent. That is what we need. Speed at that point. But you can't just calculate it. You take a delta value and take that slope. But when your delta x is getting smaller and smaller, it's not like these 2 points. It becomes something like this. So that is what rate of change at this point. But for different place, it's a different thing. Again, you can take two different points, but when your delta x is getting smaller and smaller, it becomes a. So you can see we take a value and you make it smaller and smaller, right? And see what happened to this tangent, because this tangent is keep changing. But what we need is tangent. Actually, earlier it is not a tangent. But when your delta x is getting closer and closer, that is the tangent, that is the rate of change at that point. So that we make that delta x smaller and smaller and see what is the limit value, right? So that is how mathematicians build the concept of derivative or differentiation using limits. Okay, right? Anyway, we are going to revisit that. Similarly, integration, because we are more interested about y, right? අපි හැමතිස්සෙම maths කරනවා කියලා නිකන් ඔහේ අර definition එක මේ definition එහෙම maths ඉගෙන ගෙන තමයි මේ එලෝටත් නැති මෙලෝටත් නැති මිනිස්සු දැනෙන්නේ. So we are interested about y. Our main focus is y. ඇයි අපි calculus ඉගෙන ගන්න? ඇයි අපි limits ගැන ඉගෙන ගන්න? Right? So මේකට අපි වැඩිම spend කරන්න time. So then y and what? Right? What is the limit? Why we are interested in limit? දැන් අපි මේ කතා කරන්නේ ඇයි අපි limit ගැන ඉගෙන ගන්නේ? අපි limits ගැන ඉගෙන ගන්න මේ differentiation at the rate of change එක tangent එක හොයන්න. So then areas, because this area is the accumulation. This may be your distance, right? This may be your volume. So then what we do is using calculus or the concept called integration, rather than, because you don't know exactly how to calculate this area because this is a curve, some shape, not a straight line, no, right? Something like that. So then you break it into small, say, rectangular shapes. Small rectangular shapes. And then we know height you can find, because for this particular x, you know the fx. This particular x, you know the fx. This particular x, you know the fx, right? Well, the fx can x squared now, right? X එකේදී දන්නවා, දෙකේදී දන්නවා, තුනේදී දන්නවා. So then you know the heights. And if you make this into, say, small distances, then we ended up with rectangular shapes, right? But remember, then you can sum it. Sigma is summing. Okay, you sum this area, this area, this area, this area, and so on, and then you get the value. So that will be not the exactly same as the area, but something close, because there's error. But when මේ පොඩි errors තියෙනවා, මේවා හොයන්නේ නැහැ. But that error will be lesser and lesser when you make this delta x smaller and smaller. And immediately චූටි areas වලට කැඩුවොත් චූටි areas වලට කැඩුවොත් තවත් චූටි areas. That means we are going to have large number of rectangles. Earlier 100, now 10,000, 1 million, 1 trillion. But if you make that number of rectangles infinitely many, so that means that error is going to be negligibly small. Or we say that that area reach a limit to the exact area when this delta x is getting closer and closer to 0. හැබැයි මේක බිඳුව දාන්න බෑ. බිඳුව දැම්මම ඒරියා ගන්න නැහැ. You need to think about this, right? You need to think about this. සමහරට දවස් ගණන්, මාස ගණන්, ඒ කියන්නේ A level වල මේක මාස ගණනක් විතර ගන්න. හරි? හිමින්. So that is another concept very useful to calculate these areas. Okay? Right, is it clear? Is it clear? Right, so we'll take a small break. Remember, our task is understand the concepts. Right? අපේ වැඩේ concept එක තේරුම් ගන්න එක ගණන් හදනවට ඒවට වැඩිය. හරි? ඔයාගේ A level maths paper එකක් එහෙම ගත්තොත් ඔයා දැකි සමහරට සුළු කරනවා, පිටු ගණන් සුළු කරනවා. අපිට ඒක ආදාළ නැහැ. හරි? I'll show you a, say, A level එක ශ්‍රී ලංකන් හරි edexcel හරි ඕන එක ඒව තමයි. හරි? see. අපි ලංකා A level paper එකක් ගමු. ශ්‍රී ලංකා combined maths marking scheme, say 2026 25 තියෙනවද දන්නේ තියෙන්න ඕනේ maths paper. අපි English medium කරගමු. අපි ඕන එකක් ගමු. English paper වල වෙනසක් වෙන්නේ නැහැ. marking scheme. 20 hari, 20 hari, 21 hari, whatever. This is paper only. Let's say 2021. We have the English. Okay, forget about single or English, right? Because maths is maths. Okay. Maths is maths, but we should be able to find English one. So you can see this is all everywhere you can see limits. You can see limit. Oh, and yeah. You can see limits. This is a very, very core concept, right? And lock now paper download කරන්න සල්ලි දීලා ගන්න කියලා. Let's download. Right. So this one, applied paper, PO paper. Forget about the single English, okay? So I'm just showing the importance of limits. Okay, so you have done this NCR, right? NCR මතකද ඔයගොල්ලෝ කරා? Semester. You can see everywhere we need limits. Okay, everywhere we need limits. So this is integration, right? Integration, differentiation, right? So it's a very core concept, very core concept. Okay. You can see delta values. So what I'm explaining is this is a very important concept in maths. Okay, very important concept in maths to understand. You can see again limits is there, sigma notation. Okay, because it's everywhere. So these things we will be doing, right? Matrices ඔයගලන්ට තියෙන linear algebra. Okay. ඔයගලන්ට ඔය A level maths syllabus එක සෑහෙන ප්‍රමාණයක් කව වෙනවා. හරි. ඒකද ඔයගොල්ලෝ A level maths කරපු අය ආවා කියලා බය වෙන්න ඕනේ නැහැ ඊට පස්සේ. හරි. ඒගොල්ලෝ අපිට වැඩි වැඩෝ කියලා. So this is all about calculus. මේ තනිකර මේව හොයන්නේ calculus වලින්. හරි. මේ අවකලනය කළ වෙලා තියෙන්නේ. හරි. You can see everywhere D, right? Okay, so it's volumes everywhere because we need to face a reality, right? Engineers, right? Because world is three-dimensional. World is not only straight lines, right? World is full of curves. So this is not engineering. This is A-level maths. Okay, this is A-level maths. So that now remember, right? So they have very good thinking power then, right? If you have done it in a proper way, right? So then they will look at software development, right? When there's a software development or AI engineering, data science, so you must have that same kind of a attitude, same kind of a potential to tackle that problem, right? So I know that when it comes to final year project, right, about 50% of the student, right? So they are not comfortable doing that project. That means you don't have that capacity. You have not built your capacity, confidence, right? It's not about the calculus. It's about your Java, web development, understanding requirements. Maybe you're not still serious, right? You are not aware of the real world complexities. So that is why you need to learn more and more advanced concepts, abstract concepts. Okay. Right after the break, we will continue with our discussion on limits. So then we will move on to differentiation because we are just going to look at the concept, right? We don't do a lot of that kind of heavy calculations and so on, right? We are just touching the surface, but serious man. Okay, right. So now it's 8:55. We'll start at 9:10. Okay, so let's continue. Right. So this is now we are going to define what is limit is, a formal definition. Okay. Because once you understand the limit only, I showed you that marking scheme of the level maths, right? Pure maths part. You can see a lot of places we need to use limits because sometimes you can't straight away calculate, but we can see what is the pattern. Okay. Right. So basically limit is when we have a function or relation, we reach a particular value rather than substitute or assign the value, or we reach it either this way or that way or both way, and then we see what happened to this function. Is it going to reach to a particular value? If so, that is your limit. That is your limit. For example, when we are getting closer and closer to a, my fx value is getting closer and closer to this particular value. That is when you go from negative side, keep increasing it towards a, or you start something bigger than a and keep decreasing until you reach a. Again, you can see that my fx is getting close to this particular L. So then I can write it. This is just a notation. Remember, math subject is based on axioms, axioms, notations of and theorems. So this is a notation. Remember, this is a notation, right? For example, this in sets we have notations, right? So sigma is a notation. Okay, sine is a notation. Log is a notation. So similarly, now we use the notation LIM, limit. Limit when x is getting closer and closer to a, what happened to fx? Say that value is, if that value is particular value, say 10 or whatever, you write it like this. So when x is getting closer and closer to a, uh, fx, that is this function, because it can be anything, getting closer and closer to a. So then we say limit when x getting closer and closer to a, my fx is getting, actually what we formally write is something like this. My fx is, just give me 1 minute, my pen is not working. Okay, so it's something like that. Actually, my fx is getting close and closer to L. But rather than getting close and closer to L, because anyway we are using the word limit, so therefore we can just say equal, because we use the word limit here. Limit means reaching. So therefore again you don't need to say like that. You just say equal L. Okay, it's just a notation. Right? It's just a notation. Maybe my fx is x, fx is x squared, fx is ln x, right? Fx is x squared plus 5, right? As I told you, more than 99% of the time, this limit is same as when you assign the value. For example, if this is x squared, limit x tend to 5, x squared will be 25. That is 5 squared is 25. Yes, this will be the case most of the time. But this may not be the case in some times. So those are the places where we are really, really depending on the concept of limit. But this kind of situation, maybe you may find that, okay, this is useless. Yes, I'm not saying useless, but this is how you understand the concept. But there are situations, here you have a value, but by substituting, either you can't find the value or that value is not determined. Okay. Okay. But from here, using this concept, we can find the value. Okay. That is where the concept use of limit is really, really important, because otherwise you can simply substitute. Okay. So then this limit can be either two-sided limit or one-sided limit. Now we are a little bit getting into the concepts, okay, maths, the theory behind limits or the calculus. So it can be that limit can be two-sided limit or one-sided. One-sided limit can be either right-hand limit, that is only right-hand limit, or left-hand limit. right? Because sometimes your right hand limit means you are coming from right to that value, A. Left hand limit means you are going from left towards that. That means say if this is 5, you start from 4, 4.5, 4.9, 4.99. That is your right hand limit. Say you start from somewhere like 6 or whatever, or even 10, 10, right? 7, 6, 5.9, 5.5, 5.1, 5.01, 5.001, getting close to 5 from right hand. So that is called right hand limit. Sorry, left hand limit because you are going towards left, right? So usually when you are going left hand limit, sorry, I think I have made a mistake. Right hand, yeah, you are coming from right, you are going from left. Yeah, left hand limit is starting from negative side, right? Negative side, you are going there. Right hand limit means you are coming from positive infinity side. Okay. So therefore, sometimes we say if this is A, this is A minus, this is A plus. So that means you are getting closer and closer to A from lesser values, right? That is what we mean by here. You are getting closer and closer to A, but you keep reducing it from positive side. You are going towards the negative side. Okay, so this is another notation we use. But if it is two-sided limit, you use both this and this together. So that means you take this limit as well as that limit. Okay, right. Right. So this is an example where there's a two-sided limit, one side limit, and again one side limit. So here you can see this function exists only up to this point. It is not, or maybe my domain start from A. Right? It is not defined lesser than A. So then from this side you can't reach because you don't know there's no value for no definite value here lesser than A. So therefore you can't go like this. Okay? You can't go like limit uh, x tend to A minus fx because this function is not defined below A, lesser than A. But bigger than A, it's defined because A is your point. So then you have this limit x tend to A from positive side fx. So this is a one side limit, right? Only this limit exists. In this case, you can go from negative side, but you can't come from positive side because it's not defined. So let's say not defined. This is the endpoint of the function. So then you have this limit, right? But not the right hand side limit. But if you take this kind of a point where your function is defined, right, lesser than A as well as bigger than A, then you can come this way as well as that way. So then you don't specify A plus or A minus, just say A, that means both A plus and A minus is the same. Okay, so that is two-sided limit. So there are situations we have two-sided limit. There are situations we have only left limit. There are only right limits and so on. Okay. And also, it's not always when we reach A. So A is like 5, 10, minus 3, half, 12, 1.1, 0. Sometimes we are interested what happens when my value is keep increasing infinitely. Positive infinity or negative infinity. So that means even you can think of what happens when x is getting bigger and bigger in positive side. Right? Say limit fx when x is getting bigger and bigger infinitely. Or maybe limit of fx when x is getting smaller and smaller, or negative side magnitude is getting bigger and bigger. That means this is your Cartesian plane. This is we are going towards plus infinity. This is you keep moving towards minus infinity. What happens when you are going towards minus infinity? Your fx, right? Because sometimes you have this kind of a graph. Okay, it's going like this. So when you are getting closer and closer to plus infinity, this is getting closer and closer to 3. It won't go beyond 3, but it is getting closer and closer to 3. So then you can say if this is my fx limit x tend to plus infinity, fx equal 3, right? So there are such situations. Therefore, it's a limit, but we keep increasing x. So then what happened to my fx? Okay. Sometimes when I keep increasing x, my fx also keep increasing, like y equal x squared or y equal x. So then we say limit when x tend to plus infinity, my fx is also plus infinity. Therefore, this can be infinity, but maybe this is not infinity. Or this is infinity and this is also infinite, like this. Like y equal x squared, y equal x, or something like this, where this is limiting to a region to a particular value. These are the interesting place areas. So therefore, your limit can go to infinity or your result can reach infinity, right? Your limit can reach infinity, result can, or sometimes both. Your limit is also going towards infinity and your result is also going towards infinity. Okay. Or you can maybe you are going towards zero, here you are reaching towards infinity. Or here you are going towards infinity, here you are reaching towards zero or any other number. Remember, zero is just like any other, zero is just a number, but infinity is a concept. But we don't care whether it's zero, infinity, or number. When it comes to limits, we can play with all these things. But in normal arithmetic, you can't play with infinity. But now we can play with infinity, right? When we use limits. That is additional advantage. Okay. So you can see some situations like that. So now you can see all of a sudden, if you are afraid of this kind of a graph, right? Now you have better terminology, right? Better terminology, right? For example, y equal x squared. We say that when x getting close, bigger and bigger, like infinity, my y is also fx is, right? Now maybe you're comfortable with sin x graph, but maybe you're not comfortable with tan x graph, right? Tan x graph, because it goes like that. So these are limits when x tend to say this particular value, your fx tend to plus infinity, right? So that is, for example, so that means you are, this is to give you more comfort, confidence, right? Not to scare you. Mathematics is all about building people who can handle complexity, right? Say tan x, uh, you see, it's going towards infinity, but again, coming from minus infinity, going towards infinity, coming from minus. Remember tan 9, sorry, tan 90 is infinity, right? Tan 0 is 0, but tan 90 is infinity. So that kind of things you can better understand. Right? For example, here, when x limit into the infinity, my fx is limit into this L. When x limit to plus infinity, getting closer and closer to plus infinity, my fx is getting closer and closer to L. Okay, from positive side. Here, when my x is getting closer and closer to negative infinity, right? Negative infinity, my fx is getting closer and closer to L. That is x reaching minus infinity, fx equal L. Here x reaching plus infinity, right? So now when you write like this, we know that this is not going to cross L. It's getting closer and closer to L, but it's not going to cross my L. Right? එහෙම වෙන්නේ නැහැ. එහෙම වෙනවනම් මෙහෙම ලියන්න බෑ. Right? The more you getting closer and closer to the minus infinity, this is getting more and closer, more and more closer to L. It doesn't go beyond L or get away from L. මෙහෙම ගිහිල්ලා ගිහිල්ලා ආයෙ මෙහෙම වෙන්න බෑ. මේ ඉල් කපාගෙන පහළට යන්නත් බෑ. එහෙම වෙනවනම් මෙහෙම ලියන්න බෑ. Okay? And this is where when x is getting bigger and bigger, go towards plus infinity, my fx also going towards plus infinity. That's the difference in R. And this is where when you getting closer and closer to A from, right? This side, my fx is getting closer and closer to plus infinity. Here, when you are getting closer and closer to A, right, my fx is getting closer and closer to infinity. Pay now. ඒ පැත්තට යන්න යන්න එයා අනන්තේ පැත්තට යනවා. ඒ කියන්නේ මේ අනන්තයට යනකොට අනන්තයට යනවා නෙමෙයි. ඒට ලං වෙන්නේ අනන්තයට යනවා. සමහරට මේ පැත්තේ මේ පහුවෙච්ච ගමන් සමහරට මේ පැත්තේ මතුවෙන්න පුළුවන්. Right. It depends. So therefore there are so many possibilities, right? Scenarios that you can't just think without limits. You can't think these, but now you can think about these things and build concepts with the help of limit, because limit is not assigning the value, getting closer to that value. Getting closer to that value. Okay. So this is another way of visualizing it. I already explained that. This is two-sided limit. Say when you want to go limit to the 2, say this is fx limit when x tend to 2, what happened to fx? Say if my fx is x squared, right, of course 2 squared is 4, we can just assign something like maybe 3, then it is 9, 2.5, then it is 6.25, right? We are getting closer and closer to 2 from this side. And you can see we are getting closer and closer to 4, right? It's getting closer and closer to 4. Okay. Actually, you can see this is smaller than this. 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 4.41 is smaller than 6.2. Right? So if you reach somewhat more closer to this 2 than this, that is 2.00000001, that will be even smaller than this. That means we are getting closer and closer to 4. From this side, we are getting closer and closer to 4. You can see this is closer than to 4 than this. This is closer than 4 than this. This one is even closer, even closer. So if you say 1.9999999, that will be even closer to 4. But it will never go beyond 4 as long as you are below 2. So that means that is called sandwich. Sandwich වෙනවා. Actually, in calculus, there's a theorem called sandwich theorem. So that means from this way also you are getting closer to 4. From this way also you are getting closer to 4. Then we can say limit fx, in this case, of course, x squared equal 4. In this case, this is same as when you substitute 2 here. But there are situations when you substitute, the value is not determined. Okay. Right, is it clear? Right? Is it clear? Right. So rather than you assign the value, you check when we reach the value, right? From left, from right, if it is both two-sided or just from one side, like these situations. Sometimes it may reach to infinity, sometimes it may reach to a value, sometimes we try to make it bigger and bigger, smaller and smaller. So many possibilities. Right. So once you understand the concept of limit, you can self-understand differentiation integration. So the most important thing is the basics, right? For example, if you don't understand what numbers are, right, that's the end of the story, right? So that is why again today I asked what is rational number, irrational number. What is a number? What is negative? What is zero? Because if you don't know what is negative, what is zero, right? What is a rational number? What is a number? So then you can't even go beyond that. Now you build on what is limit, what is infinity, okay? What is two-side limit? What is one-side limit? What are the possibilities for a limit? It can limit to a number. It can limit to an infinity. You can think of limiting to an infinity, like extend to infinity. Right. So another very important concept to understand limits and calculus is sequence and series. Right? Sequence and series. Right? So you can understand calculus and limits through algebra. Algebra, that is what we have discussed so far, right? Like y equal x squared. What happened when x reach into 3, right? You have an idea about the graph and so on. So then you try to see what happened to this. That is, you try to understand the concept of limit and later other calculus concept using algebra. So that is one way of understanding limits and calculus. There's another way because same concepts can be understood, or you can look at those concepts from some other concepts. So another way of looking at limits is from using the concept of sequence and series. Right? Sequence and series. Sequence and series is nothing to do with the algebra. It's about number patterns. Right? Number patterns. For example, this is a sequence, right? Samantara Shreni, Gunottara Shreni is series. So 2, 4, 6, 8. So this is a sequence. Simplest sequence is like 1, 2, 3, 4. Or maybe that means there's a pattern so that you can keep telling what is next, what is next. For example, 1, comma, 2, comma, sorry, 1, comma, 4, comma, 9, comma, 16, comma, 25. This is a sequence because I can say next one is 36, 49, 64, 81, 100. So if you can keep telling what is next value, it's a sequence. But there are some special sequence like arithmetic sequence, Samantara Shreni. You have common difference. Then geometric sequence, Gunottara Shreni, like 5, 10, 20, 40, 80, 10 divided by 5, 2, 20 divided by 10, 2, 40 divided by 22. So then we have Tn is ARn minus 1. Here Tn is A plus n minus 1 times D. Right? Then you can find the sums, right? Here is Sn is n divided by 2 times A plus n. Here Sn is A times 1 minus R to the power n divided by 1 minus R. So these are special sequences, right? Don't think that we have only two type of sequences. Arithmetic sequence and geometric. Samantra Shreni, Gunotra Shreni, Mevar Shreni. Right? So this is also sequence. Any pattern. This is 1 square, 2 square, 3 square, but this is not a arithmetic or geometric. This is also sequence. 1, comma, 2, comma, 3, comma, 5, comma, 8, comma, 13, comma. So you can see 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 5 is 13. Then next one is 13 plus 8. If there's a pattern, it's a sequence. Right? So then if you write that as a summation, so rather than 2, comma 4, comma 6, comma 8, you write 2 plus 4 plus 6 plus 8 plus, so then you call it a series. So basically this Sn formula is find the sum or it's the next value. Okay. Because it's sum. 2 plus 4 is 6. So that is S2. S2. 2 plus 4 plus 6, 12. That is S3. Right? Using this formula, you can calculate. So then you call it series. So sequence and series are highly related because you can convert your sequence into series by summing. Right? So therefore you have arithmetic series, geometric series, and anything else. Even something like this, you can make it a series. Right? So when it comes series, we use sigma notation because sigma means sum. 1 plus 4, 1 plus 4 plus 9. That is sum of 3 terms. Sum of 4 terms, sum of 5 terms. So this Tn or An is for sequence, nth value. Sn is sum up to this point, sum up to n values. Yes. So that now you should know the difference between sequence and series. Because when you do these things in O level, you are concentrating on just two type of sequence and series, right? That is arithmetic sequence and series, geometric sequence and series. But in mathematics, our next level is consider it as a general concept. That is called abstraction. You don't just concentrate on now. Remember, in rather than you look at arithmetic as base 10, right? So in semester 1, you learn that, okay, we can do arithmetic operation in any base. Add, subtract, multiply, divide into base 2, base 5, base 12, base 25, or base 100. So that gives you more confidence about what is addition, what are arithmetic operations, what are numbers. You know that even decimal number like 12.73 can be represented in binary, and you can add those numbers in binary. So likewise, sequence and series also, you must understand it as a general concept, right? General concept. Because this is a very, very good way to uh, understand limits and then integration, uh, differentiation concept, or basically limits. Okay. So this is another useful concept for us to get a better sense about limits. That is understanding sequence and series in general sense, rather than just concentrate on the two special types, arithmetic and geometric. If there's a pattern, right? If you write it comma separated, it's a sequence. And same thing if you write it as a summation, it's a series, right? It's a series. And if you have infinite number of terms, we call it infinite sequence. That means you don't stop somewhere. You don't stop. For example, 2, comma, 4, comma, 6, comma, 8, comma, 10, comma, 12. So let's say you stop there. That means you are not interested more than first, second, third, fourth, fifth, sixth term. That means we have only 6 terms, nothing more. Then it is a finite sequence because you are not interested anything beyond that. But if you keep, there's no limit, right? So there's no limit saying, okay, the 6 term, no, it can go on. So then you get infinite sequence. So again, there's no limit. Okay. So same thing can happen to series. Sometimes you stop somewhere. After 5th term, you are not interested, or you don't care. It goes forever. So then it's an infinite series. Okay. So this infinite sequence and infinite series are very interesting concepts to understand limits. Right? Understand limits. Okay. Right. So when it comes to sequences or infinite sequences, okay, now you know what is infinite sequence is. That is a sequence where you don't think about the in last term. It can go forever. Okay? So these infinite sequences, like infinite sequences can be either convergent or divergent. Okay. So that means your infinite sequence can be either convergent or divergent. Okay. So either it's a convergent sequence or it's a divergent sequence. Every infinite sequence, right? Every infinite sequence is either divergent sequence or convergent sequence. So what is mean by divergent sequence? So divergent sequence means your infinite sequence, infinite value is a infinity, or it's infinite. Or there are two possibilities, right? So when you write your sequence, if you can see by looking at the pattern, my infinite term is either plus infinity or minus infinity. Then it is a divergent sequence. That is the case 1. Okay. Case 2 is your sequence is oscillatory. That means it goes this or that, this or that. That is how it goes, like this or that. Go to this value, come back to that value. Then again, go to this value, come back to that. Again, go this value, come back to that. Go this value, come back to that. So then again we say it's divergent. So those are the two possibilities. Either it's your infinite element is infinity, or limiting to infinity, or your sequence is oscillatory. Oscillate again, පැද්දෙනවා. In those cases, we say that our sequence is divergent. Right? For example, the very good simple example is 1, comma, 2, comma, 3, comma, 4, comma, and so on. What is the hundredth term? 100. Millionth term? Million. Trillionth term? Trillion. Then infinite term? Right? So remember, trillion is bigger than million or billion. So then trillionth term is trillionth of trillion. Or then lakshana laksha, million, million. So remember, infinity means you keep increasing as a concept now. Don't think it as a number. As a concept, you are making it bigger and bigger term. Right? So then your value is also getting bigger and bigger. Actually, you can see that your hundredth term is 100, then millionth term is million, trillionth term is trillion. So then infinite term must be logically infinite. Is it clear? Do you have any doubt about that? Or do you want to, or you feel like, no, I want to challenge that answer? Yes, you can do it. That is how you learn things. That is what critical thinkers, right? If you don't agree with that, you say that I don't agree. Simple as that. So that is what critical thinkers do, right? I am a critical thinker. For example, if I don't agree with you, I will say I don't agree. ඒක ඔයාගේ මූන්ට කියලා යන්න මම. ගියාට පස්සේ වෙන අයට කියන්නේ එහෙම නැහැ. කියන්නේ ගණන්කාරයෝ කියන්නේ. ගණන්කාරයෝ කියන්නේ right? Logical thinkers. It doesn't mean that I am correct. Maybe I am wrong. But I will find that I am wrong when I have your discussion with you, right? Dialogue. සමහරට මම ඔයාගේ මූන්ට කියනවා ඔයා වැරදි කියලා සමහරට හෙට ඇවිල්ලා කියනවා ඔයා හරි කියලා. That is fine because I am not a perfect person, right? But you must have the guts to say that uh, no, I feel like you are wrong. That is how you learn. Critical thinkers learn, keep learning things, right? So they challenge, they make mistakes. But others, they accept things because of fear, because of they are lazy to think. So therefore, again, if you feel like when I say by looking at the pattern, you should see that the infinite term is getting towards infinity. Like මම කිව්වන් දා විශ්වාස කරන්න ඕනේ නැහැ. Then you can say, no, I feel like it is not getting towards infinite. Maybe it's getting close to something else. So yes, you can talk. Maybe we can discuss. ඒකෙන් ඔයා පල් වෙනවා එහෙම එකක් නැහැ. Right? Maybe you learn something, maybe I will learn something. Or we will all learn something. Maybe you have a logic. Okay? Right. So therefore, this kind of a sequence definitely by infinite term is when I say definitely, right? මගේ මතය ගන්නවා හරි. මම මට තේරුම් ගත්ත විදියට මට උගන්වපු අය explain කරාට පස්සේ මම තේරුම් ගත්ත විදියට. This is definitely getting towards infinity. But if you feel like you have a challenge for that, yes. Right. Right. So this is easy to understand because 100 term is 100, 10,000 term is 10,000, but not necessarily like that. For example, what about this 5, comma, 10, comma, 20, comma, 40? This is the first term, second term, third term, fourth term. So then what happened to the fifth term? Fifth term is 80. Now I can't say that 100th term is 100, right? But 100th term is definitely bigger than 100. Well, the fifth term is 80. Ne? Earlier, millionth term is million. But now you can see that my million term is even bigger than million. So then what happened to my infinite term? So then someone will say, okay, it must be bigger than infinity. No, because infinity is not a number. Infinity is the concept of very large. So it's a concept of very large. So therefore, your infinite term is infinitely large number, big, right? Not the trillionth number, even bigger than trillionth number. So therefore, remember the 100th term is bigger than 100, then infinite term must be, you can't say bigger than infinity. It must also be infinity because infinity means very large. It's a concept. Right? It's a concept. It's not a number. Okay. So therefore, yes, infinite term must also be very large. How large? Infinitely large because you are thinking about infinite term. Right? Infinite term. So therefore, there are some sequences. Your infinite term is infinity. So then it's divergent. Like this. So that then pattern එක බලලා කියන්න පුළුවන් වෙනවා. Right? For example, 5, 10, 20, 30. This is geometric series sequence. 20, 40, 80, where r equal to. So this is again you can see divergent because it's keep getting bigger and bigger and bigger. So okay. Second possibility is oscillatory sequences are also divergent, like +5, -5, +5, -5, +5, -5. Then maybe your second, you can see it's odd number, it's +5, 1, 3, 5. So then what about 999 term, +5? What about thousands term, -5? 1001th term, +5. 1002nd term, -5. So then what about the infinite term? So you can't say whether it's +5 or -5. We can say that it's either +5 or -5. But remember, infinity is not a number. So therefore, we don't know whether infinity is odd or it doesn't make sense to think about whether infinity is odd or even. Because if it is a odd situation, +5, even situation, -5. So therefore, in this kind of a situation, no, because we can't exactly say whether it's +5 or -5 or anything like that. So again, we put it into divergence for different reason, right? Different reason, right? So this is how you write it. Limit when n tend to infinity, nth term is infinity, or nth term is maybe this so that plus a or minus a, or something like plus a or minus b, or plus a or plus b. එහෙම වෙන්නත් like 2, 3, 2, 3, or +2 -2 වෙන්නත් නැහැ. Oscillated. +10 +20, +10 +20. Still oscillated. Okay. So by convention, no, because it's not convergent, අපි ඒකත් ගන්න divergent කියලා. හැබැයි but this divergence and this divergence is two different concepts because this is getting to infinity, this is just oscillating between two values. Okay. But we just put it into the divergent again. Okay. Right. So that means, so but now this is not the interesting scenario. Right. This is the boring scenario. There's interesting scenario. That is where we have convergent sequences. Right. Convergent sequences. So convergent sequence is the interesting that. So we say that a sequence is convergent if the infinite term, again it must be infinite sequence, right? Infinite sequence. We say that an infinite sequence is a convergent sequence if its infinite element is a finite value or limit to a finite value. That's interesting. Right? You can see maybe වචන වලට වැදගත්. මොකද මැත්ස් කරපු අයගේ හොඳ කමියුනිකේෂන් ස්කිල්ස් තියෙන එකයි. මොකද ඒගොල්ලෝ හැම වචනයකටම වග කියනවා. හරි. ඒ කියන්නේ ප්‍රෝග්‍රෑමින් කරන අයට මැත්ස් කරන්න කියන්නේ මොකද ප්‍රෝග්‍රෑමින් කියන්නේ කමියුනිකේෂන්. You communicate the solution to the computer. Right? Prompt engineering කියන්නේ communication. You communicate your requirement and expected result to the AI agent. AI agent එක වැඩ කරන්න නම් ඔයාලට හොඳට communicate කරන්න ඕනේ. කතන්දර කියන්න ඕනේ. ඒක තමයි prompt engineering කියන්නේ. Prompt engineering. The prompt engineer ගේ job එක තමයි මොකද්ද? හරියට communicate කරන එක. Software engineer communicate job එක මොකද්ද? හරියට solution එක communicate කරන එක. ඒකට communication skills පට්ට වැදගත් කියන්නේ. කොහොමද හරියට communication skills හදාගන්නේ? Right? So you know what is communication is. And logical thinking. Logically කියන්න ඕන හරියට යාළුවා. Right? Logical thinkers are ලස්සනට communicate කරනවා. So they are the best communicators. Right. So if you have a sequence where the infinite element is either infinity, the infinite element is a finite value or limit to a finite value. So then we say it's a convergent sequence. We have such sequences. There are such sequences. So let's take the scenario one. What about the sequence? Remember, sequence means you can keep telling the next one. And you know that the next element is 5, next element is 5, next element is 5, because look at the pattern. Right? Look at the pattern. So then what about the millionth element? 5. Trillionth element? 5. Trillionth of trillionth element? 5. Infinite element? 5. Do you have any doubt? What සැකයක් තියනවද? Assume that you have given enough terms to identify the pattern. ඔයාට pattern එක අඳුර ගන්න අවශ්‍ය ප්‍රමාණයට දීලා තියෙනවා. ඒ කියන්නේ ඊට පස්සේ pattern එක වෙනස් වෙන්නේ නැහැ. හරි? pattern එක වෙනස් වෙන්නේ නැති හන්දමයි මෙතන නවත්තලා තියෙන්නේ. මේ ඔයාට අවශ්‍ය ප්‍රමාණයට තමයි data දෙන්නේ. So then of course your trillion term must also be 5. Then infinite term must also be 5, right? Because according to this pattern. So then of course my infinite term of the sequence is 5, which is a finite value. Right? So therefore, this is convergent sequence, not 5 comma 5, right? Minus 3, minus 3, minus 3, minus 3, 5, 5, 5, 5, 5, 0, 0, 0, 0, 0, then it's converged to 0 and converged to 10 and so on. Right, that is also not very interesting, right? It's obvious, right? So second one is interesting one. There are some sequences, the infinite term limit to a finite value or converge to finite value. So then we call it convergent sequence. That is, now this is also convergent sequence, but the second scenario is also convergent sequence. So this is more interesting scenario. Let's take an example. Say I have sequence. Remember, sequence means you can see the pattern and always keep telling the next, next, next forever. Can you see a pattern? 1. Okay, let's write it as 1 divided by 1. 1 divided by 2, 1 divided by 3, 1 divided by 4, 1 divided by 5, 1 divided by 6. Then what is the next term? 1 divided by 7. Right? 1 divided by 8. That is 8th term. 100th term, 1 divided by 100. Millionth term, 1 divided by million. Trillionth term, 1 divided by trillion. So then someone asks, what is the value of infinite term? So that is very large, even go beyond, right? Keep going, keep going, right? So if you keep going towards infinity, what happened to your term, value of the term? Remember 1 divided by 10, 1 divided by 100, 1 divided by million, 1 divided by trillion. So what about the infinite term? You can't say what is the infinite term. To which value your infinite term is getting closer and closer to. Getting closer and closer to. So remember this is 1, this is 0.5, this is 0.33, this is 0.25, right? So this is 0.2 and so on. Then 1 over 10 means 0.1. You can see it's getting smaller, right? What then 1 become half, 0.5, then 0.33, 0.25, 0.2, 0.1. 1 over 100 0.01. 1 over 1000, 0.001. 1 over trillion තවත් 0.000001. So you can see this is getting smaller and smaller. But do you think that this is getting lesser than 0? It's getting closer and closer to 0, right? Because 0.2 is closer to 0 than 1 or 0.5. 0.1 is closer to 0 than 0.2. 0.01 is closer to 0 than 0.1. 0.00001 is closer to 0 than. But do you think that this is getting beyond 0? ඔකට හිතනවා මේක බිඳුව පහ කරගෙන ඍණ පැත්තට යයි කියලා. මොකද දැන් මෙහෙම එනවා දැන් මේ 1.5 0.1 0.001 දැන් කාලට හිතනවා එහෙනම් කොහොම ගිහලා 0 පහ කරගෙන දැන් ඊට -0.1 -0.2 එහෙම වෙයි. But do you see such a possibility? Just use your common sense. Oh, pattern. That is called your IQ. Right? No. ඉතින් මම නෝ කියන හන්ද පිළිගන්න එපා. ඔයා කල්පනා කරන්න. ඉතින් ඔයා yes නම් ඔයා කියන්නේ මෙන්න මේ හන්දයි yes කියන්නේ කියලා තමයි. හරි? So it's getting smaller and smaller, but I don't see any pattern possibility of it's getting smaller and smaller towards zero, but it's not going to go beyond zero and be a negative number. So therefore, in such a situation, we say that limit a nth term when n is getting to infinity, that is called infinite term, is in this case zero because this is getting closer and closer to zero. 0.01, 0.001. Right? It's getting close and closer to zero, but it's not going to go beyond zero like that. Okay? මේ කඩාගෙන යන්නෙත් නැහැ. මෙයා එන්න එන සෑන්ඩ්විච් බිඳුවට එන්න එන තුරුල් වෙනවා. එන්න එන තුරුල් වෙනවා හැබැයි බිඳුව පහ කරන් යන්නේ නැහැ. මේ සමහර ඉන්නවා නේද? මෙයාට එන්න එන්න මෙයාට තුරුල්ලා ටිකක් වෙලා ගියාම වෙන කෙනෙක්ට තුරුල්ලා ඉන්නවා. එහෙම වෙන්න බෑ. සෑන්ඩ්විච් එන්න ඕනේ එයාටම විතරයි. Right? So that is also called a convergent sequence because it's limit to a particular value, infinite term. So there are such sequences. Right? So this one example. This is another example. Right? So this is another interesting example. Right? If you can tell the next one, it's a sequence. 1 divided by 2, 2 divided by 3, 3 divided by 4, 4 divided by 5, 5 divided by 6, 6 divided by 7, 9 divided by 10, right? 10 divided by 11, 99 divided by 100. Yeah, just 999 divided by 1000. AC one even. Right? 9,999 divided by 10,000. What about this? What about so this is first term, second term, third term, fourth term, fifth term, ninth term, 10th term, 99th term, 999th term, 9,999th term. You can see that it's getting closer and closer to 1. This is half. This is 0.33. This is 0.75. Right? So this is 0.8. Right? This is 0.9. This is 0.99. 0.999. 0.999 is closer to 1 than 0.99. So then it will be 0.9999. But you can see that when you go towards infinity, this is getting bigger, but it is never going to go beyond 1. They are sandwich and here they cut. Right? It's getting close and close to 1, but it will never go beyond 1. So then we can say limit for this particular sequence, n term when n tend to infinity is 1. If the infinite term limit to a finite value, because these are finite values. So then also it's a convergent sequence. Convergent sequence. Now you can understand that there are such patterns in numbers. Number වලත් එහෙම තියෙනවා. නම්බරයක් පුළුවන් එහෙම එකකට වෙන නම්බර එකට ලං වෙන්න. එන්නේ. ඉස්සරහට යනකොට. So this is the boring scenario, but still convergent. But this is an interesting scenario, right? So there are so many such patterns where your infinite term limit to a finite value. So then we say it's a convergent sequence. Now you can see to understand these concepts, we can use the concept of limit. Right? Within limit කියන concept එක. Okay. දැන් අපි මෙතන මේ functions එන්නේ නැහැ. මේ number පැත්තෙන් එන්නේ දැන්. හරි එක එක පැති වලින් වාට එන්න පුළුවන් මේ concepts වලට. Okay. Right. So that is another approach or another way of using the concept of limit to understand numbers, number sequences, number patterns. Right. So then the series. So when it comes series, things become more interesting. Right. When I use the word interesting, it's more challenging and exciting. Okay. Challenging and exciting. ඔබ දන්නවනේ සිරීපාදනයකට වැඩිය අමාරුයි එවරස් නගින්න. නැත්නම් පිදුරු තලාගෙන ඉතින් කන්ද මුදුනට යනකම පාර තියෙනඳ අවුලක් නැහැ මං කියන්නේ. පයින් යනවනේ. හරි. හැබැයි එයාට වැඩි එක්සයිට්මන්ට් එක තියෙන්නේ කොහොමද? උසම කන්දකට නැග්ගම. හරි. අමාරු දෙයක් කරා. අමාරු දෙයක් තේරුම් ගත්තාම. So therefore It's more challenging, at the same time, it's more interesting. Right? Understanding series, especially infinite series, because now we keep adding these values as there's a pattern and we keep adding. And at any time we can say what is S5, what is S6, right? S9, right? S100, S trillion, or S infinity. What is the summation of infinite terms? Now we sum most. Okay. So again, if your series ends somewhere, it's a finite series. That means only 10 terms, 20 terms. But if you keep adding, it's an infinite series. Your infinite series can be again convergent or divergent. Most of the time divergent, but there are convergent series. That is very interesting. Okay. Remember the summation has something to do with the summation එක පෙන්නන්නේ කොහොමද sigma වලින් එකතු කරලා. Right? For example, sigma 1, 2, sorry 1 plus නැත්නම් 1 plus 2 plus 3 කියන්නේ sigma තමයි ඇත්තටම. හරි? 1 plus 2 plus 3 plus, so therefore what is the nth term? n වෙනි පදේ මොකද්ද? Third term is 3, then nth term is n. අපි ඔක ලියනවා sigma n කියලා. Okay. Sorry, sigma r r equal 1 to n. So because first r is 1, then 2, sigma means sum. Then you stop at n, 1 plus 2 plus n. But if it is infinite series, we just say infinity. You can remember n වලින් නවතිනවා දිගටම යනවා. 1 plus 2 plus මෙන්න මේ sigma notation. ඔය sigma තමයි අපි ටිකක් වෙලා ගියාට පස්සේ integration කියලා ලියන්නේ. right? Continuous වුණා. මේ වගේ gaps නැහැ. මේක continuous නැහැ. There's a gap 1 to 2, 2 to 3. But when there's no gap, this sigma become integration. Okay, sigma become integration. ඒකන්ද මේක අපිට සම්බන්ධයි පස්සේ integration වලටත් ආ. හරි. ඒතකොට මේ sigma කැපන්දර වලත් අපි limits ලියන්න පුළුවන්. මම marking scheme එකේ පෙන්නනවා. ඒ කියන්නේ sum එක limit වෙනවා. marking scheme පෙන්නන්නේ නැත්නම් ඔයගොල්ලෝ හිතනවානේ මේ එක එක විකාර කියලා නෑ. marking scheme එක අපි ගත්තා. මෙතනනේ sigma limit වගේ. This is A level, right? යටද. Can see sigma වෙන අபிසාරී මෙතන අபிසාරී කියන්නේ convergent. Right? Convergent. හරි. u0 කියලා. So this is a limit of sum. Limit of sum 1 to n where n tend to infinity. N tend to infinity. So that is another place where we can use limit to understand, because remember your series can be, yes, most of the series are divergent, right? Most of the series are divergent. That means sum of infinite term is infinity or oscillatory. Now this time sum. For example, if you take, say we have a series. Sequence is 1, 1, 1, 1, 1, 1, or 2, 2, 2, 2, 2, or 5. Okay, up to 5 here. 5, 5, 5, 5, 5, 5. Goes forever. Now, what is this a divergent sequence or convergent sequence? Anyone? And then ඔළුවට ගිය කට්ටිය උත්තර දෙන්න ඕන. This is a sequence, right? Because I can tell the next term.
Convergent.
Sorry? Convergent or divergent?
Convergent.
Divergent.
Convergent sequence.
Convergent sequence. Why?
Because it bound to finite value.
You must tell its infinite term is a finite value, right? Its infinite term is a finite value. That value is 5. Okay, so therefore this is a convergent sequence. Convergent sequence. What about the series? From any sequence, you can build a series. Just make it a sum. Now, what about this? Is it a convergent series or divergent series? Divergent means your sum of infinite term is uh, infinity or oscillatory. Convergent means sum of infinite term is a finite value or limit to a finite value. Now my question is this is a convergence sequence. Now I create a series from that. Is this a convergent series or divergent series?
Divergent.
Divergent. Why?
Because summation of the infinite value is also infinite.
Yes, that's it. Right? Because sum of two terms is 10. Sum of three terms is 15. Sum of four terms 20. There are pattern appearance. Then sum of 100 term must be bigger than 100. Sum of 1000 term must be bigger than 1000. Then sum of trillion term must be bigger than trillion. Then sum of infinite term must be, you can't say bigger than infinite because infinite is not a number, but it's also very large. So if infinite is very large, this must be even bigger, right? If it's an even bigger katawa kiyanna, it's also infinity because infinity is a concept. So therefore, this must be a divergent series. So you can see, though the sequence is convergent, your series can be divergent. Series can be divergent. Right? Even something like this 1 comma 1 comma 1 comma 1 comma, if you made a series, this is divergent. This is convergent, but this is divergent. Right? This is divergent. So lot of series are divergent. Most of the time when you look at a series, right, it's divergent. Sometimes you may feel like every series must be divergent. එහෙම වුණාට මුලින් sequence දකින්න නැත ඇත්තේ නේද? Every series sequence must be convergent කියලා අපි පස්සේ දැක්කනේ. මෙහෙම sequence තියනවා කියලා. Right? Convergent sequence. Similarly, there are divergent sequences. Sorry, similarly, there are convergent sequences. Remember, if sum of infinite term is infinity or oscillatory, it's divergent. Right? So this is uh, sum of infinite term is infinity. These are all divergent by looking at the pattern. But what about this oscillatory sequence? So sometimes sum is 2, sometimes sum is 0. Even number of terms, sum is 0. Odd number of terms, sum is 2. Right? So therefore, if you take million terms, million is even, that means 0. But million one, sum plus 2. So therefore, again, because we don't know whether it's not determinant to say whether infinity is odd or even. So therefore, it can be either 0 or plus 2. If we have more than one possibilities, again, we call it divergent. So therefore, this is also divergent series. Of course, this is divergent sequence as well as divergent series. Of course, for every divergent sequence, we get a divergent series. But uh, not every divergent, sorry, not every convergent sequence ended up with convergent series. Right? Sometimes your convergent sequence ended up as a divergent series, like this. It's a convergent sequence, but divergent series. Sometimes divergent sequence, divergent series. Right? If it is oscillatory, of course, both divergent sequence and divergent series. But the interesting thing is there are some convergent sequences where the series also convergent, but not every convergent sequence is divergent sequence series. Sorry, not every convergent sequence is a convergent series. but there are some convergence sequences where the series is also like convergent. Okay, so let's look at that kind of an interesting scenario now. So this is such a scenario, right? So this is a convergent sequence. Okay, convergence sequence, because it's getting closer and closer to zero. This is 0.5, this is 0.25, right? 0.4, and so on. So not 0.4, this is 1 divided by 8 means 1, 8, 2, 1.125 and so on. But it's getting closer to zero. Therefore, this is a convergence sequence. This is a convergence sequence, right? And again, if you analyze 1 plus, this is some S1 is 1, S2 is 1.5, S3 is 1.75. That is 1.5, 0.5 plus 0.25. And if you keep adding these, you will find that, not you will feel like, you will find that this is getting close and closer to 2. Now, if you add this term, right, again, you can see it's getting closer to 2, but usually you will feel like, okay, this is getting, this will go beyond 2 as well, and then be infinite because you keep adding, 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 adding. Right? Your intuition, gut feeling will say, you are keep adding things, right? Or make it හැමදාම add කරනවා. Right? හැමදාම add කරනවා. So every term, say, every day you get a one term that you add it, right? This time not value, this time you add it. So sometimes you may feel like, say you are going for ever, right? Ever. So you may feel like, okay, this is going to be feel forever, right? But in reality, this won't go beyond 2, right? Go beyond. The sum is not going to go beyond 2 in this case, right? So this is the hardest thing to understand. මේක තමයි තේරුම් ගන්න අමාරුම කතන්දරය මේ sequence series වල. අරකට තේරුම් ගන්න පුළුවන් කියන pattern එක දිහා බලලා. මේක මේ වගේ ඒවා මේ වගේ නේද? ඔයා පේනවනේ මේක බිඳුවට ලං වෙනවා මේක එකට ලං වෙනවා කියලා. මේක 99 බෙදීම 100. 999 බෙදීම 1000. ඒකත් නිකන් හරි තේරෙනව නේද එන්න එන්න. හැබැයි මේක තමයි හිතා ගන්න අමාරුම එක. හිතා ගන්න අමාරු දේවල් වෙනවා සමහරවිට. අමාරුයි කියන්නේ impossible නෙමෙයි. So you keep adding, right? You keep adding forever, but the sum is not going to go beyond 2 in this case. Sum, not the value. Sum is getting close to 0, right? The value is getting close to 0. The sum is going to getting close and closer to 2, but it will never go beyond 2. It's sandwiched to 2. Okay? Sandwiched to 2. Right? So that if you keep looking at the pattern, you will better understand. Right? And of course, if you want, you can write a program. මේ වගේ program එකක් ලියලා එකතු කරලා බලන්න කීයද වෙන්නේ කියලා. දවසක් තිස්සේ රන් වුණොත් මේක දෙක පහ වෙන්නේ නැහැ. අතන මේ ටිකක් වෙලා යනවා දශම වෙලා වගේ overflow වෙලා යනවා. accuracy එක computer එකට manage කරගන්න බැරි වෙනවා. හරි. decimal places 100 ගානකට ගියාට පස්සේ. by special computer එකක් වට දාන්න පුළුවන්. But by looking at this pattern, we can prove that in rigorous proofs, there's a way to prove these kind of things. මම A level එකට ඔයගලන්ට උගන්වන්නේ නැහැ කියලා මෙතනදී. හරි ඔය prove කරන විදියක් තියෙනවා. ඒකට අපි කියනවා delta epsilon proof එකක් කියලා. So that using those concepts we can prove that this limit to 2. It's getting closer and closer to 2 but not go beyond 2. So this is a convergence series. This is another convergence series. There are so many such convergence series. That means your infinite sum is getting closer to a number, but not go beyond that. Not go beyond that. ඕක තමයි ඉන්ටිග්‍රේෂන් වලත් වෙන්නේ. මේක පොඩි කරනවා එන්න පොඩි කරන්න මේ වැලියු එක අපිට හරියටම කියන්න පුළුවන් මේ ඒරියා එක 5යි කියන. ඕක 5ට වඩා වැඩි වෙන්නේ නැත. හරි. කොහොමද කරන්නේ? අපි මේක චූටි කරනවා. ඉන්ෆයිනයිට් චූටි කරනවා. Then this is getting closer and closer to 5. Then you can say this fx from say 0 to 1 or 0 to 3 equal 5 කියලා බය නැතුව කියන්න. සම් එක තමයි ඔය 5 වෙන්නේ. සම් එක තමයි. නැත්නම් මෙහෙම සිග්මා ලිව්වේ n tend to infinity හරි. මේ an equals say 3 කියලා එහෙම ලිව්වේ. ඔප්පු කරන්න පුළුවන් ඒවා. එදාර A level paper වල අහලා තිබුණා. අපි ඒක ඔප්පු කරන්නව කරන්නේ නැහැ. ඉතින් හරියටම කියන මේක 2යි. මේක 1යි. වෙනවා. අන්තිමට කියනවා මේක මේ වැලියු එක 2යි. So this sum of infinite terms. Right? So you can say, okay, no, that's 2. That's 3. So that means the convergent series. Right? Convergent series. Abhisari, apasari. Okay. So therefore, we have such a concept. We have such sequences, series in reality. Right? Convergent sequences, divergent sequences. A convergent series, divergent series. Then you must understand, okay, every divergent sequence results in every divergent sequence results in divergent series. Right? But not every convergent sequence results in convergent series. Most of the convergent sequences result in divergent series, but some convergent sequences result in convergent series. Okay. ඒකට උදාහරණ තමයි මම දැන් පෙන්නුවේ. So this is a convergent sequence but divergent series. Right? This is a convergent sequence but divergent series. But this is a convergent sequence, right? And convergent series. Convergent sequence because infinite term is 0. Convergent series because sum of infinite term is 2. Now හිතන්න කොහෙන්ද මේ මැජික් එකක් වගේ 2 වෙන්නේ? ඒවට තමයි ලිමිට්ස් තියෙන්නේ. ඒවා තේරුම් ගන්න තැන ලිමිට්ස් තියෙන්නේ. කොහොමද මැජික් එකේ 10.9 10 divided by 9 වෙන්නේ? නේද? මේ එකතු කරනවනේ අනන්ත ගාණක්. ඒතර අනන්ත ගාණ එකතු කරනකොට ඔයා කොහොමද තියෙන්නේ හරියටම 10 බෙදීම 9 කියලා. මේක 10 බෙදීම 9 කිය හරියටම කියන්නේ කොහොමද? Using limits. So I'm just explaining the use of limits, the power of limits. Okay. So therefore you can get into this subject from sequence series side, relations and function sides. Right? Because the same concept at the end. Same concept, two different approaches. So two different paths to understand. Okay. Right. So maybe you are wondering how do you say that this is 2 for your information? This is a very special type of a series. This is a geometric series. You can see this divided by this is half. This divided by this is half. This divided by this is half. Right? Both these are geometric series. This divided by this is 1 over 10. Mea divided by mea. Again 1 over 10. So this is common ratio is 10, 1 over 10. This is common ratio is half. If you have geometric series where your common ratio is between -1 to +1, this is half is between -1 and +1, right? That is not 0, right? Maybe plus 1 over 3, 3 over 4, minus half, minus 1/3, minus 3/4. So those series are convergent. A series convergent now. But there are other series also like convergent, but this is just for you to ඒ series ලක්ෂ ගාන infinite ගානක් තියෙනවානේ. But not only those are convergent, right? So there are some other series also, just a set of examples for you to understand. If you have a geometric series where the common ratio is between -1 and +1, those series are always converged. And these series converge to, remember, Sn is a times 1 minus r to the power n divided by 1 minus r. But if your r is between -1 and +1, your S infinity is a divided by 1 minus r. So in this case, a is 1, right? Divided by 1 minus 110. That is 1 divided by 9 divided by 10. That is 10 divided by 9. 10 divided by 9. Here A is 1, R is half. 1 divided by half is 2. ඒ වගේ අපිට හරියටම කැල්කියුලේට් කරන්න පුළුවන්. මේක ඔප්පු කරන්න පුළුවන් හරි. මේක මෙහෙමයි කියලා. මේකෙන් මේක ගන්න පුළුවන් when n actually this is basically limit when n tend to infinity sn. හරි. ඒතකොට මේවට අපිට theorems තියෙනවා. ඔප්පු කරපුවා ඒවෙන් අපිට මේක ඔප්පු කරන්න. හරි. Right. So therefore remember sometimes the sum also can limit to a value. Not only the value is limit to a value. Okay, sum. That is how you get integration and so on. Okay, right. So now that's it about limits. On that limits I have not explained you everything about limits, but I have explained you reasonable depth. What is limit and how do you think about the limit of a particular value, limit of a sum. Can become a limit C no a limit take limit n when n tend to infinity or limit sigma n when tend into infinity. So this is sequence, this is series. So then again you can look at it from like this. Available, two-sided limit, one-sided limit. Right? So most of the time your limit value is same as the sign value, but there can be situation the sign value is not the limit. Okay. Sometimes the sign value you can't think of, but limit is there. And they are in infinite series. එකපාරට හිතාගෙන බලනකොට limit එකක් එනවනේ හරියටම භාගයයි 9න් 10යි. Right. So then you need to understand differentiation and integration. So that we will discuss in another session. Right. Again, we are not going into all the rules and so on and them අපි ගණන් හදන්න කියන්නේ නැහැ නේද? මම මේ තනිකර concept explain කරා විතරයි. එක ගානක්වත් ඇදුවේ නැහැ අතන ඔයගොල්ලොත් එක්ක. හරි. So similar approach, we are going to look at differentiation and integration. Okay. Now you can see we are almost halfway. So then we will move on to maybe we need one more session because that is very important. It's investment for you. ඇත්තටම ඊළඟ සෙෂන් එකේ තමයි ආට අර කන්ෆිඩන්ස් එක බිල්ඩ් වෙන්නේ. අවකලනේ අනුකලනේනේ ඔයගොල්ලෝ එකපාරට බය හිතෙන්නේ. දැන් ඔන්න ඒකට ඇතුල් වෙන්න අපිට පුළුවන්. හරි. ඒකට ඇතුල් වෙන්න පුළුවන්. හරි ඊට පස්සේ ඔයාලට පුළුවන් ඕන දෙයක් මේ A level මැච් කරා කියලා බය වෙන්න එපා. ඔයාලට කලින් ඉන්ටර්විව් කරේ A level මැච් කරපු එක්කෙනෙක් කියලා. හරි නැත්නම් එයා මැච් දන්නවා කියලා ඔයගොල්ලෝ දන්නවා. මොකද විවෘත තරංකාරී ලෝකෙට ගියාට පස්සේ ඔයගොල්ලෝ ඕන එකක එක හැප්පෙන්න ඕන. හැප්පෙනවා කියන්නේ තරහ කර නෙමෙයි. ලෝකෙ එහෙම තමයි තරංකාරී. ඕකේ? ක්‍රිකට් මැච් එකකට යන්න දිනන්නනේ. හරි? චෙස් ප්ලේ කරන්න දිනන්නනේ. බැඩ්මින්ටන් ගහන්න දිනන්නේ. හරි පරදින එකත් it's part of your life but you want to win also, right? Right, we stop at this point. Thank you.